They call it a twin. But not the kind you've met. Not the kind with a heartbeat and a shadow that walks beside you. This twin resides 30 million light-years away, floating in the vastness of the southern sky, cradled in the quiet arms of the constellation Pavo. Its name is NGC 6744, a grand, sweeping spiral galaxy that mirrors the Milky Way in form, but not in fate. When astronomers point their most powerful eyes toward the heavens and stumble upon NGC 6744, they do not just see another swirling city of stars. They see a reflection, a potential echo of our own galaxy's journey through space and time. And as we look deeper into its golden core, into its spiraling arms, and into the galactic secrets written across its dust lanes and starlit filaments, we are not just observing it, we are observing ourselves. Or perhaps, what we might become. But before we continue, subscribe to the channel so you don't miss out on any of these videos. NGC 6744 is one of the most magnificent spiral galaxies visible from Earth, yet it remains a whisper in the lexicon of the cosmos. Unlike the Andromeda Galaxy, which so often steals the spotlight, NGC 6744 is content to keep its secrets tucked within the silence of intergalactic space. But silence is not emptiness. It is often filled with the loudest truths. And in the case of NGC 6744, that truth is radiant with stars, bursting with ancient energy, and dancing to gravitational rhythms billions of years in the making. This galaxy is categorized as an intermediate spiral galaxy, a classification that places it somewhere between tightly wound and loosely coiled, a symbol of cosmic balance, as if it's caught mid-breath between chaos and order. It stretches more than 175,000 light-years across, making it over 1.5 times the size of the Milky Way. That staggering scale alone renders it one of the largest nearby spiral galaxies ever observed with such clarity. But beyond its size, it's the structure, the architectural poetry of starlight and darkness, that has left astronomers in awe. Its sweeping arms are filled with regions of intense star formation, known as H2 regions, glowing with newborn stars like constellations yet unnamed. These arms spiral outward from a bright yellowish core, an older population of stars humming in lower energy frequencies, the elderly guardians of galactic memory. This core, like the Milky Way's, is likely home to a supermassive black hole. Though we cannot yet peer into the heart of that darkness with complete clarity, the energetic echoes suggest its presence is undeniable, shaping everything from gas motion to the distribution of stellar populations. What makes NGC 6744 even more compelling is that its face is almost perfectly turned toward us. This near face-on orientation offers a clear and unobstructed view into the structure of the galaxy. Its arms, dust lanes, star clusters, and radiant bursts of new stellar nurseries. This is a gift in observational astronomy, akin to looking at a masterpiece not from the side, but directly from the front row. It allows astronomers to trace the arms, to study the star-forming regions, and to analyze the chemical composition of its interstellar medium in exquisite detail. One of the galaxy's most enchanting features is its asymmetrical fourth arm, less defined and more dispersed than the others. This faint structure suggests that NGC 6744 has experienced past galactic interactions, most notably with its satellite companion galaxy, NGC 6744a. This smaller galaxy is akin to the Magellanic Clouds that dance around our own Milky Way. These interactions are not merely passive. They are dynamic, gravitational ballets where galaxies pull, twist, distort, and sometimes merge into one another. These interactions may have triggered waves of star formation, sculpted the outer arms, and enriched the galactic disk with heavy elements forged in the hearts of dying stars. And then there is the color, the visual fingerprint of a galaxy's life story. NGC 6744's central bulge radiates with a soft yellow hue, indicative of older, redder stars. These stars are relics of ancient cosmic epochs, survivors of countless galactic revolutions. They form the structural backbone of the galaxy, offering stability amid the turbulent birth of younger stars further out in the disk. In contrast, the spiral arms gleam with the faint bluish-white light of massive, short-lived stars, young, energetic giants that burn fast and die young. These are the torchbearers of the galaxy's ongoing evolution, lighting up the clouds of gas from which they were born. But not all is light. Interwoven with this brilliance are dark filaments of cosmic dust, molecular clouds cold enough to block starlight but dense enough to eventually birth new stars. These shadowy tendrils stretch like veins through the galactic disk, sculpting the arms and hosting the potential for countless generations of star formation. They are the wombs of the galaxy, hidden nurseries veiled in molecular silence. NGC 6744 is located within the Pavo group, a cluster of galaxies that interact gravitationally. This galactic family is part of the larger Centaurus supercluster, an expansive, sprawling web of galactic structures that defies the imagination. These cosmic hierarchies remind us that even the grandest spirals like NGC 6744 do not exist in isolation. They are members of a larger chorus, each contributing their own frequency to the cosmic symphony. It was first catalogued in 1826 by James Dunlop, a Scottish astronomer observing from Australia, using a relatively modest telescope by today's standards. But what Dunlop saw was enough to etch this galaxy into the astronomical records. Over the centuries, technology advanced, and the shrouded features of NGC 6744 began to emerge in higher detail. With instruments like the Hubble Space Telescope and the European Southern Observatory's Very Large Telescope, astronomers have since peeled back more of the galactic veil, revealing not just its structure, but its behavior, its tendency to birth new stars, to interact with its environment, and perhaps even hint at a deeper, older narrative written across the fabric of its stars. Understanding NGC 6744 means exploring not just what it is, but what it was, and what it will become. It's a story of transformation. A story of rotation and radiation. A story of gravity's subtle whispers and time's relentless passage. Every star is a timestamp, every gas cloud a sentence in the biography of this cosmic behemoth. And still, for all we have observed, there remains much we do not know. What is the exact mass of its central black hole? What role did satellite interactions play in shaping its spiral structure? What are the metallicity gradients across its disk? How does its star formation rate compare to galaxies of similar mass? These are not trivial questions. They are vital to the comparative study of spiral galaxies, to galactic archaeology, and to understanding the evolutionary fate of our own Milky Way. Yet in every mystery lies an invitation, a beckoning to keep watching, keep calculating, keep questioning. NGC 6744 is not just an object of distant study. It is a cosmic mirror, reflecting the path we are on, and perhaps the destiny that awaits us. NGC 6744's story deepens when we examine its internal mechanics, how it breathes, rotates, and transforms over cosmic time. Galaxies are not static. They are in constant motion, and NGC 6744 is no exception. Its arms rotate in a majestic, sweeping spiral, taking hundreds of millions of years to complete a single turn. Stars, gas, and dust are pulled along this rotation, obeying the invisible grip of gravity and the galactic potential well that guides their path. The core, denser and more massive, rotates more rapidly than the outer edges, a phenomenon known as differential rotation. This means that stars in the inner disk complete their orbits faster than those on the galactic outskirts, leading to the stretching and winding of spiral arms over time. The spiral arms themselves are not merely paths etched by stars. They are density waves, regions where gas is compressed, triggering bursts of star formation. These waves move more slowly than the stars themselves, creating areas of increased pressure and density where clouds collapse into protostars. This dynamic process means that NGC 6744 is not only a galaxy of age and memory but also one of birth and change. The light we see from these newly formed stars travels for millions of years before reaching Earth, which means we are constantly looking at the galaxy not as it is, but as it was, a natural time machine providing a window into a cosmic past. Star formation within NGC 6744 is both robust and regionally diverse. The arms are dotted with brilliant knots of stellar nurseries, known as H2 regions, clouds of ionized hydrogen gas lit up by the ultraviolet radiation of massive young stars. These glowing pink and red patches are the most visually striking parts of any spiral galaxy, and in NGC 6744 they are spread throughout the disk in a patchwork that reveals the galaxy's active and ongoing formation history. The strength of these regions hints at a relatively high star formation rate, suggesting that NGC 6744 is not in a passive phase but continues to convert interstellar material into brilliant stars and planetary systems. The interstellar medium within the galaxy plays a crucial role in this life cycle. It consists of molecular clouds, atomic hydrogen, ionized gas, cosmic dust, and magnetic fields. The presence and distribution of molecular hydrogen, in particular, is a critical ingredient for the formation of new stars. Astronomers using radio telescopes have been able to map this gas through emissions like the 21-centimeter hydrogen line, revealing a surprisingly rich and complex web of matter that threads its way throughout the disk of NGC 6744. This gas, slowly collapsing under its own gravity, is the lifeblood of the galaxy's ability to create new stellar generations. Dust, while often seen as an obstacle in optical observations, is also a valuable asset in understanding the galaxy's ecosystem. The dark lanes observed in NGC 6744's arms, those opaque, sinuous patterns that obscure the stars behind them, are regions of dense dust. These are often the same areas where molecular clouds form, acting as the scaffolding for future star formation. Dust grains absorb starlight and re-emit it in the infrared, allowing space telescopes like Spitzer and the James Webb Space Telescope to penetrate these dark regions and reveal the processes hidden within. Yet the distribution of dust is not uniform, nor is its presence benign. Dust absorbs light from the central regions, particularly in spiral arms, and can skew measurements of star counts, brightness, and even chemical abundances. To account for this, astronomers utilize multiple wavelengths, optical, infrared, radio, and ultraviolet, to piece together a more complete picture of the galaxy. Through this multi-wavelength approach, the hidden complexity of NGC 6744 emerges, a system not only governed by gravity and mass, but also by radiation, temperature, and the subtle interactions between gas and dust. But what truly elevates NGC 6744 to cosmic fame is not just its physical structure or chemical composition, it is the striking resemblance to our own Milky Way. This resemblance is not superficial. The size, morphology, presence of a barred central region, and similar satellite systems all suggest a profound structural kinship. When we study NGC 6744, we are essentially holding a mirror to our own galaxy, allowing astronomers to study a Milky Way analog from the outside, a perspective that is otherwise impossible due to our position within our own galactic disk. Imagine trying to understand the full layout of a city while living in one of its buildings. You can't see the entire design, the scale, or the patterns that emerge only from distance. That is our limitation with the Milky Way. NGC 6744, then, is like being lifted into the sky and shown the full map, its arms, its bulge, its halo, and its faint outer reaches. This comparative approach has proven invaluable. For instance, the star formation rate in NGC 6744 offers a proxy for what the Milky Way may be experiencing. Its galactic rotation curve, how orbital speeds vary with distance from the center, helps refine our understanding of dark matter distribution in galaxies like our own. Its satellite interaction with NGC 6744A allows us to draw parallels with the small and large Magellanic Clouds, which are gradually being assimilated into the Milky Way. Dark matter, that elusive, invisible substance that makes up the majority of the mass in the universe, plays an enormous role in NGC 6744's structure and stability. While we cannot see dark matter directly, its presence is inferred through its gravitational effects, most notably the flatness of galactic rotation curves. In a galaxy without dark matter, we would expect stars further from the center to orbit more slowly, just as planets further from the Sun take longer to complete an orbit. But in galaxies like NGC 6744, stars in the outer disk orbit at nearly the same speed as those closer in. This discrepancy implies that there must be a massive, invisible halo of dark matter enveloping the galaxy, providing the additional gravity needed to hold the stars in place. This dark matter halo is not just a curiosity, it is the framework upon which the galaxy is built. It influences everything from the rate of galactic mergers to the formation of spiral arms. It is a silent architect shaping the destiny of NGC 6744, and by extension, it gives insight into how dark matter might be shaping our own galaxy at this very moment. Advanced simulations that include NGC 6744's structure, stellar population, and dark matter component are helping to refine models of galaxy formation and evolution on cosmic scales. Even the halo of NGC 6744, the region beyond the bright disk, holds clues to its past. This faint, extended region contains older stars, globular clusters, and possibly remnants of past mergers. It is within this stellar halo that the long-term memory of a galaxy resides. The stellar halo is difficult to observe, but deep exposures and image stacking have begun to reveal its secrets. These include metallicity gradients, how heavy elements vary with distance from the core, stellar streams, the remnants of absorbed dwarf galaxies, and rare ultrametal stars that date back to the early universe. Indeed, the chemistry of NGC 6744 is one of its most telling attributes. The galaxy contains stars of varying metallicities, an indicator of age in star formation history. Younger stars tend to be more metal-rich because they are born from clouds enriched by the deaths of earlier stellar generations. Older stars, formed during more pristine cosmic conditions, are metal-poor. By analyzing the spectra of stars and gas in NGC 6744, astronomers can reconstruct its chemical timeline, when star formation peaked, when gas inflow occurred, and when past galaxies were absorbed. And there is even more to uncover in terms of high-energy phenomena. Like many large spiral galaxies, NGC 6744 is expected to emit in X-rays and gamma rays, due to the presence of black holes, neutron stars, supernova remnants, and hot gas in its interstellar medium. These energetic emissions are less visible in optical wavelengths, but they provide critical information about the galaxy's violent past and present. X-ray emissions can trace the remnants of supernova explosions, cosmic events that seed galaxies with heavy elements and trigger new waves of star formation. These remnants often form expanding bubbles of hot plasma, which can be observed in both X-ray and radio wavelengths. NGC 6744's high-energy phenomena are not limited to the aftermath of stellar deaths. The galaxy may also host several X-ray binaries, systems where a normal star orbits a compact object like a neutron star or black hole. In these systems, material from the star is pulled toward the compact object, forming an accretion disk that heats up to millions of degrees and emits copious amounts of X-rays. The study of such systems in NGC 6744 provides clues about its population of end-stage stars and the frequency with which massive stars collapse into exotic remnants. These are essential data points for astronomers trying to model stellar life cycles on a galactic scale. While the precise number of black holes in NGC 6744 remains unknown, statistical analysis based on its size and star-forming history suggests there could be tens of millions of stellar mass black holes scattered throughout the disk and bulge. Some of these may be active, gobbling up matter and radiating high-energy light. Others may remain dormant, silent but significant gravitational actors in their local environments. There may even be an intermediate mass black hole lurking in one of its dense star clusters, a fascinating prospect for astronomers seeking to understand the missing link between stellar black holes and the supermassive ones found in galactic centers. Speaking of the central regions, NGC 6744 almost certainly harbors a supermassive black hole at its core, as nearly all large spiral galaxies do. Although it's difficult to observe directly due to the great distance and intervening dust, indirect signs like stellar motion patterns and radio emissions can hint at its presence. If this central black hole is accreting material, even at a low rate, it might emit radiation across the electromagnetic spectrum, particularly in radio and X-ray wavelengths. Instruments such as the Chandra X-ray Observatory and the Atacama Large Millimeter/Submillimeter Array, ALMA, are often used to investigate such emissions in galaxies like NGC 6744, though conclusive identification remains challenging at this distance. But NGC 6744 is more than a testbed for astrophysical phenomena. It's a living system shaped by interactions and evolution. One of the most intriguing aspects of its recent history is its relationship with a smaller companion galaxy, NGC 6744a. This irregular satellite is currently interacting with the spiral host, possibly being cannibalized in slow motion as its stars and gas are drawn into NGC 6744's gravitational grasp. These galactic mergers, especially when involving small companions, are common in the universe and play a critical role in galactic growth. The interaction with NGC 6744a can spark bursts of star formation by compressing gas clouds in both galaxies. It can also stir up the outer regions of NGC 6744, inducing distortions in the spiral arms or triggering tidal tails, those long, sweeping streams of stars pulled out into space. Some simulations suggest that galaxies like NGC 6744 may have experienced dozens of such mergers over billions of years, each one contributing new stars, gas, dust, and dark matter to the system. These events are part of the galaxy's biography, and they leave behind subtle scars, twisted arms, misaligned gas streams, disrupted star clusters, and shells of stars in the halo. To uncover these scars, astronomers use tools like deep photometry and spectroscopy. They look for regions with abnormal metallicity, clusters with unusual velocities, or structures that don't align with the galaxy's rotation. Each clue adds a page to the story of NGC 6744's past, revealing a system that has grown, fought, digested, and evolved over cosmic epochs. And through that process, it has come to resemble the very galaxy we call home, not just in appearance, but in behavior and complexity. Zooming out, the location of NGC 6744 in the universe provides even more context for its evolution. It resides in the constellation Pavo, approximately 30 million light-years away, placing it well outside the local group but still within the nearby universe. Its relative proximity allows us to study it in detail, while its position makes it part of a broader filamentary structure of galaxies, the cosmic web. Galaxies like NGC 6744 do not evolve in isolation. They are embedded in a larger gravitational framework shaped by dark matter and the expansion of space itself. Their motions, interactions, and even star formation rates are influenced by this cosmic environment. NGC 6744 is part of a galaxy group, clusters of gravitationally bound galaxies that orbit a shared center of mass. While it is the dominant member of its group, its interactions with nearby galaxies contribute to the exchange of gas, radiation, and even high-energy particles. Cosmic rays, high-speed atomic nuclei, and electrons can originate in supernovae and travel across intergalactic distances, affecting the chemistry and magnetism of neighboring systems. The ambient radiation environment, shaped by quasars and active galactic nuclei in the larger cosmos, can also impact how galaxies like NGC 6744 form and evolve. From Earth, observing NGC 6744 requires large telescopes, often mounted in the southern hemisphere due to the galaxy's position in the sky. The European Southern Observatory's Very Large Telescope, VLT, and facilities in Chile have contributed significantly to our understanding of this magnificent spiral. Over time, astronomers have compiled high-resolution optical images, radio maps, infrared spectra, and ultraviolet scans. Each wavelength peels back another layer of its mystery. In visible light, we see the structure; in infrared, the dust; in ultraviolet, the young stars; in radio, the cold gas; and in X-ray, the remnants of death and the seeds of rebirth. These observations are not mere data. They are profound glimpses into the history of a galactic leviathan. When we gaze at NGC 6744, we see a structure nearly 175,000 light-years across, one of the largest spirals in our corner of the cosmos. Its central bulge gleams with the yellow light of ancient stars, perhaps billions of years old. Its arms spiral outward in sweeping, symmetric curves that suggest stability and maturity, punctuated by hot blue stars and glowing nebulae. This duality, of youth and age, order and chaos, light and dark, is the essence of the galaxy's appeal. There's a quiet poetry to NGC 6744. It's not just a star city or a dust-filled spiral. It's a storyteller. Each photon it emits tells a story that began millions of years ago. Some of those photons began their journey when early hominids walked the Earth. Others were born when dinosaurs still roamed. And yet, they travel tirelessly through the void, carrying the messages of a galaxy that has existed for billions of years, waiting for someone to look up with curiosity and decode them. The future of NGC 6744 is equally compelling. Like all large galaxies, it will continue to evolve, merging with smaller companions, forming new stars, cycling gas through stellar processes, and gradually transforming. In perhaps tens of billions of years, it may exhaust its gas, its spiral arms may fade, and it could become a more spheroidal, quiescent galaxy. Or, depending on gravitational influences, it could merge with another large galaxy and form a massive elliptical. These are not just speculations. They are statistically likely outcomes based on our observations of galaxies across the universe. The very fact that we can tell this story is a testament to the power of human inquiry and the reach of our technology. From a speck on a pale blue dot, we are able to study a galaxy 30 million light-years away, understanding its anatomy, history, and destiny. NGC 6744 stands as a beacon of what is possible when we look up, ask questions, and persist in our search for answers. It reminds us that even in the silent darkness of deep space, there are wonders waiting to be revealed. And so, as we continue our cosmic journey through this essay, remember that every word, every fact, every theory we explore about NGC 6744 is part of a broader human story, the story of discovery, of wonder, and of an enduring connection to the universe around us. As we dive even deeper into the intricacies of NGC 6744, it becomes essential to explore the very fabric that binds it together, its interstellar medium. This diffuse matter that drifts between the stars and the galaxy is not mere filler. It is the raw material from which stars are born and into which they return at the end of their lives. In NGC 6744, the interstellar medium, or ISM, is rich, dynamic, and multifaceted, composed of neutral atomic hydrogen, molecular clouds, ionized gas, cosmic dust, magnetic fields, and high-energy particles. The ISM in a galaxy like NGC 6744 is structured in a delicate balance between heating and cooling processes. Starlight, especially from hot, young stars, bombards the surrounding gas and dust with ultraviolet radiation. This heats up the surrounding medium, leading to the formation of ionized hydrogen regions, H2 regions, glowing beacons scattered across the spiral arms. These are places of intense astrophysical activity, lit by the radiation of new stars and often surrounded by shells of shock-heated gas from stellar winds and supernovae. Molecular clouds, the cold, dense regions of the ISM, are of particular interest. These clouds, composed primarily of molecular hydrogen, H2, are the incubators of future stars. In NGC 6744, high-resolution observations reveal vast stretches of dark lanes and filaments weaving through its spiral arms, dense with molecular material. These cold regions are opaque to visible light but glow brightly in the millimeter and submillimeter spectrum, making them observable by instruments such as ALMA. Within these clouds, gravitational instabilities can trigger the collapse of gas pockets, initiating the process of star formation. However, star formation is not uniformly distributed throughout NGC 6744. It tends to concentrate in certain regions, often tracing the spiral arms in a phenomenon known as density wave star formation. Spiral density waves are like cosmic traffic jams, patterns of higher density that move slowly through the disk of the galaxy. As gas and dust encounter these waves, they compress and begin to clump, leading to star formation. This wave-like triggering mechanism helps explain why the spiral arms appear so vibrant and active compared to the less structured areas between them. The feedback from star formation is just as crucial as the process itself. Massive stars live fast and die young, often ending their lives in spectacular supernovae. These explosions send shock waves rippling through the ISM, compressing and stirring it, enriching it with heavy elements, and sometimes triggering further rounds of star formation. In NGC 6744, the presence of multiple supernova remnants indicates a galaxy in which stellar birth and death are ongoing processes, part of an eternal cycle that shapes its structure and composition. Beyond the gaseous component, dust plays a silent but vital role. Dust grains in NGC 6744 are composed of silicates, carbon compounds, and other elements forged in the hearts of stars. Though they account for only a tiny fraction of the mass of the ISM, these grains absorb and scatter light, influence the heating and cooling of gas, and provide surfaces for chemical reactions. Observations in the infrared, particularly those from the Spitzer and Herschel space telescopes, highlight dust lanes spiraling out from the galactic center, tracing the underlying magnetic field lines and revealing the hidden structure of the galaxy. Magnetic fields in NGC 6744, though invisible to the eye, are another layer of complexity. These fields thread through the disk, influencing the motion of charged particles, guiding cosmic rays, and affecting the dynamics of the ISM. Measuring these fields involves detecting polarized light from starlight or radio emissions. Polarimetric studies suggest that galaxies like NGC 6744 possess large-scale ordered magnetic fields aligned along their spiral arms, generated and maintained by dynamo mechanisms driven by the rotation and turbulence of the galaxy. The rotation of NGC 6744 is, in itself, a point of fascination. By analyzing the Doppler shift of spectral lines from different parts of the galaxy, astronomers can map its rotation curve, how rotational velocity varies with distance from the center. Interestingly, like in many spiral galaxies, NGC 6744's rotation curve remains flat far beyond the visible edge of its stellar disk. This phenomenon provides strong evidence for the presence of dark matter, an invisible form of mass that exerts gravitational pull but does not emit or absorb light. Dark matter likely forms a vast, roughly spherical halo around NGC 6744, enveloping it like a shadowy cocoon. This halo contains several times more mass than all the stars, gas, and dust combined. Though we cannot see it directly, its gravitational influence is measurable. Without dark matter, the galaxy's stars would not orbit as fast as they do in the outer regions. They would fly apart. This mysterious substance is one of the most profound puzzles in astrophysics, and galaxies like NGC 6744 serve as laboratories for its study. As we peer further into the future, we must consider how NGC 6744 will evolve on a cosmic timescale. Galaxies are not static. They are ever-changing, slowly transforming as stars are born and die, gas is consumed or ejected, and interactions reshape their structure. Over billions of years, NGC 6744 may continue to accrete matter from its surroundings, absorb smaller satellite galaxies, and gradually build up its mass. It might also experience internal transformations. Its spiral arms could wind tighter or dissipate, its star formation may decline, and its disk may grow more diffuse. Eventually, perhaps tens of billions of years from now, NGC 6744 could merge with another major galaxy. If such a collision were to occur, it could trigger an immense burst of star formation, a starburst event, as gas clouds collide and compress on a massive scale. After the merger, the resulting system might resemble a giant elliptical galaxy, with little cold gas left and a population dominated by older stars. This is the long-term fate of many spirals in a universe driven by gravity and expansion. Yet long before that distant future, astronomers here on Earth will continue to unravel its mysteries. With new generations of telescopes, such as the James Webb Space Telescope, JWST, the Vera-C, Rubin Observatory, and future radio observatories like the Square Kilometre Array, SKA, we will be able to probe deeper into NGC 6744's core, its halo, and its star-forming regions. Each new image, each spectrum, each data point adds to our growing understanding, like threads woven into an ever-expanding tapestry of cosmic knowledge. But perhaps the most remarkable aspect of NGC 6744 is what it reflects back to us. As one of the closest analogues to our own Milky Way, it offers a rare external perspective on a structure we cannot observe from the outside. By studying NGC 6744, we gain insight not only into the nature of galaxies in general but into the very galaxy we inhabit. We learn about how our own spiral arms might look, how our own star-forming regions behave, and how the Milky Way might one day appear to a distant observer across the void. NGC 6744, in its grandeur and complexity, is a mirror and a window, a reflection of our galactic home and a portal into the broader cosmos. It stands as a testament to the universality of physical laws, the interconnectedness of all things, and the boundless curiosity of the human mind. As long as we look to the stars, galaxies like NGC 6744 will continue to inspire, to teach, and to remind us that we are part of something vast, ancient, and beautiful. NGC 6744, as an exemplary spiral galaxy, allows us to explore the deeper, often unnoticed facets of cosmic structure and evolution. It is not merely a collection of stars and gas, but a complex system shaped by forces that span vast distances and immense time scales. Let's dive deeper into the cosmic phenomena within and around NGC 6744 that reveal the incredible dynamism of this distant yet fascinating galaxy. One of the most compelling aspects of NGC 6744 is its intergalactic environment, particularly its relationship with its neighbors. While it is an isolated galaxy in the grand scheme of the universe, NGC 6744 exists within the broader cosmic web, a network of galaxies connected by vast stretches of dark matter and invisible gravitational forces. However, its immediate cosmic neighborhood plays a crucial role in shaping its future. Neighboring galaxies can influence each other in various ways, ranging from gravitational interactions that distort galactic shapes to even potential mergers that can completely alter a galaxy's structure. NGC 6744 is part of a loose group of galaxies known as the NGC 6744 group, which includes a few smaller galaxies. While this group does not exhibit the level of interaction seen in more densely populated galaxy clusters, the gravitational influences between these systems are not negligible. Over time, NGC 6744 may gradually experience some degree of perturbation due to these nearby galaxies. Such interactions could lead to subtle changes in the galaxy's spiral structure, or possibly even trigger the formation of new structures such as tidal tails or rings. In fact, one intriguing possibility is that NGC 6744 could eventually be involved in a galactic merger, potentially leading to the formation of a new, more massive galaxy. This merger could be similar to the fate of our own Milky Way, which is predicted to merge with the Andromeda Galaxy in about 4.5 billion years, leading to the formation of a giant elliptical galaxy. Galaxy interactions also serve as a reminder that the universe is in a constant state of flux. Although galaxies like NGC 6744 may appear static, they are part of a broader, ever-evolving cosmic landscape. The gravitational tides of nearby galaxies can stir the gas and dust within, leading to bursts of star formation or, conversely, causing the expulsion of material from the galaxy's disk, altering its dynamics. Even more significant, perhaps, is the effect of large-scale cosmic events on the development of galaxies like NGC 6744. The evolution of galaxies is influenced not only by local gravitational interactions, but also by the expansion of the universe itself. The ongoing cosmic expansion stretches the fabric of space-time, causing distant galaxies to move away from each other over time. While this may seem like an insignificant influence on individual galaxies, it plays a critical role in shaping the overall distribution of matter in the universe. As space expands, galaxies such as NGC 6744 become increasingly isolated, making it less likely for large-scale mergers to occur in the distant future. This expansion, coupled with the eventual gravitational influence of dark energy, may lead to a universe where galaxies are separated by ever-increasing distances. Now, let's look at how NGC 6744 fits into the larger picture of galactic classification and the processes that govern galactic morphology. NGC 6744, classified as a barred spiral galaxy, fits neatly into the Hubble sequence of galaxies. The Hubble sequence categorizes galaxies based on their shape, and barred spirals like NGC 6744 are characterized by a central bar-shaped structure from which the spiral arms emerge. This feature is a defining characteristic of galaxies in this category, distinguishing them from regular spiral galaxies, which do not have such a central bar. The presence of a bar in NGC 6744 may provide insights into the underlying mechanics of the galaxy's evolution. Bars are thought to form due to gravitational instabilities within a galaxy's disk, and they can play an important role in redistributing material within the galaxy. The central bar acts as a funnel, guiding gas and dust inward toward the core of the galaxy. This inward flow of material can trigger increased rates of star formation in the central regions, potentially fueling an active galactic nucleus or feeding a supermassive black hole, if one exists at the galaxy's center. Interestingly, the exact origin and role of bars in galaxies remain an open question in astrophysics. Some theories suggest that bars form early in a galaxy's life and remain stable, while others propose that bars evolve over time, gradually weakening or even disappearing in some cases. In NGC 6744, the bar is relatively well defined, suggesting that it may have been present for a considerable amount of time. Its ongoing presence suggests that the dynamics of the galaxy's disk are stable and that the bar continues to play a significant role in shaping the galaxy's internal structure. Bars also have an interesting influence on the shape of spiral arms. In many barred spiral galaxies, including NGC 6744, the spiral arms are tightly wound and tend to emerge from the ends of the central bar. This structure can have profound effects on the overall dynamics of the galaxy. For example, the density waves that trigger star formation in spiral arms may be affected by the presence of the bar, creating complex patterns of gas and dust flow within the galaxy. Another crucial feature of NGC 6744 is the presence of a central bulge. The bulge is a dense, spheroidal region of stars that lies at the core of the galaxy. The bulge is often home to older stars and may contain a supermassive black hole at its center. In NGC 6744, the bulge is relatively prominent and contributes to the galaxy's overall mass. Its precise structure, whether it is disk-like spheroidal, or a mixture of both, can tell us much about the history of the galaxy's formation. The relationship between the bulge and the rest of the galaxy is a key question in the study of galactic evolution. Many barred spiral galaxies have a bulge that is tightly connected to the central bar, and this connection may be responsible for the shaping of both features over time. In terms of the stellar population within NGC 6744, the galaxy is home to a diverse array of stars. Observations suggest that the galaxy has a relatively old stellar population in its bulge and central regions, with many of the stars having ages on the order of several billion years. In contrast, the spiral arms are filled with younger, hotter stars that are the products of recent star formation. This age gradient, with older stars in the center and younger stars in the arms, is typical of many spiral galaxies and suggests that NGC 6744's star formation has been a gradual and ongoing process. The presence of large-scale star formation in the spiral arms of NGC 6744 has another important consequence: the generation of cosmic rays. These high-energy particles, which are produced in supernovae and other energetic processes, are spread throughout the galaxy by magnetic fields. They interact with the interstellar medium and can play a role in the heating and ionization of gas in the galaxy's arms. Observations of cosmic rays and their distribution across NGC 6744 could provide important insights into the processes driving star formation and the dynamics of the galaxy's interstellar medium. Supernovae are another critical factor in shaping the structure and evolution of NGC 6744. These violent explosions mark the end of a massive star's life, and they release vast amounts of energy into the surrounding interstellar medium. Supernovae are known to produce shock waves that propagate through the galaxy's gas, triggering further star formation and enriching the galaxy with heavy elements. In NGC 6744, supernova remnants have been detected in several regions, indicating that the galaxy is still undergoing an active cycle of stellar birth and death. One of the most intriguing features of NGC 6744 is the potential presence of an active galactic nucleus, AGN. The center of many spiral galaxies, including our Milky Way, harbors a supermassive black hole, which may accrete material from its surroundings and emit radiation as it does. In NGC 6744, the central region appears to be relatively calm, but there is still some evidence that the core may harbor a low-luminosity AGN. Understanding the role of AGNs in galaxies is a major area of research in modern astronomy, and further observations of NGC 6744 could provide important clues about the interplay between supermassive black holes and their host galaxies. The study of active galactic nuclei, AGN, in galaxies such as NGC 6744 holds significant implications for understanding the growth and evolution of supermassive black holes, and their role in shaping the galactic environments they inhabit. AGNs, despite being relatively elusive and difficult to observe in some galaxies, are characterized by the intense radiation emitted from the accretion disk surrounding supermassive black holes. This radiation is the result of gas and dust spiraling into the black hole, reaching temperatures high enough to emit X-rays, ultraviolet light, and radio waves. In the case of NGC 6744, while there is no evidence of a particularly bright or powerful AGN, the possibility remains that, over time, the central black hole may become more active, contributing to the galaxy's growth. The nature of a galaxy's supermassive black hole is intricately tied to the galaxy's evolution. Galaxies and their central black holes often grow together, with the mass of the black hole being proportional to the galaxy's stellar mass. This relationship is known as the M-sigma relation. For NGC 6744, the central supermassive black hole could play a key role in regulating the galaxy's growth by influencing the accretion of material and modulating the rate of star formation in the core. As material from the galaxy's disk falls toward the black hole, it heats up, emitting radiation that can push gas away from the central regions, effectively quenching star formation. Conversely, the release of energy from the black hole might trigger new bursts of star formation in the surrounding regions. This delicate balance between accretion, radiation, and star formation is a fundamental aspect of the galaxy's lifecycle. One of the striking features of NGC 6744 is its vibrant star-forming regions. As with many spiral galaxies, the spiral arms of NGC 6744 are sites of intense star formation, particularly in the outer sections of the arms. These regions are often associated with high concentrations of gas and dust, which are the building blocks of new stars. The star formation rate in NGC 6744 has been the subject of several studies, and while it is not as extreme as that seen in more actively star-forming galaxies like the antennae galaxies, it still demonstrates the ongoing process of stellar birth that is characteristic of many spiral galaxies. The spiral arms of NGC 6744, like those in other galaxies, are shaped by a variety of mechanisms. One of the most important is the spiral density wave theory, which posits that spiral arms are not permanent structures but rather density waves that propagate through the galactic disk. These waves compress gas and dust as they move outward, triggering new star formation in the regions of greatest density. The resulting burst of star formation generates intense radiation and winds, which can further influence the evolution of the galaxy. The interaction between these density waves, the gravitational forces at play, and the motion of stars and gas creates the beautiful and intricate spiral arms that we see in NGC 6744. Interestingly, the spiral structure of NGC 6744 exhibits some differences from that of other well-known barred spiral galaxies. For instance, the arms of NGC 6744 appear to be relatively symmetric, which suggests that the spiral density waves are relatively stable. This symmetry contrasts with the more disturbed arms observed in galaxies undergoing recent interactions or mergers, where tidal forces can distort the spiral structure. The relatively undisturbed nature of NGC 6744's spiral arms suggests that it has experienced minimal interactions or external perturbations, allowing its spiral structure to evolve in a more orderly fashion. The star-forming regions of NGC 6744 are characterized by the presence of HI regions, which are areas of ionized hydrogen gas. These regions are typically found around young, hot stars, and their detection is an important marker of ongoing star formation. The gas in these regions is heated by the ultraviolet radiation emitted by the young stars, causing it to glow in various wavelengths. In NGC 6744, these HI regions are scattered throughout the spiral arms, providing valuable insights into the processes driving star formation within the galaxy. The study of these regions also helps astronomers determine the metallicity and chemical composition of the galaxy, as the elements present in the gas can tell us about the history of stellar evolution and nucleosynthesis in the galaxy. In addition to the star-forming regions, NGC 6744 contains numerous older, redder stars that populate its central bulge and outer disk. These stars are the remnants of earlier generations of stellar populations and provide important clues about the galaxy's history. The study of stellar populations within NGC 6744 allows astronomers to reconstruct the galaxy's formation and evolution. By examining the age, composition, and distribution of these stars, scientists can infer whether NGC 6744 formed through a gradual process of accretion and merger or whether it experienced more dramatic episodes of star formation. As with many galaxies, NGC 6744 is subject to the influence of dark matter, which plays a critical role in shaping its overall mass and structure. Dark matter is an invisible form of matter that does not emit, absorb, or reflect light, making it impossible to detect directly. However, its presence can be inferred through its gravitational effects on visible matter. In galaxies like NGC 6744, dark matter is thought to be concentrated in a large, diffuse halo that extends well beyond the visible galaxy. This dark matter halo provides the additional gravitational pull needed to explain the observed motions of stars and gas in the galaxy. Without dark matter, the outer regions of galaxies like NGC 6744 would be unable to hold together, and their stars would be ejected into intergalactic space. The study of dark matter and its effects on galaxy dynamics is one of the most active areas of research in modern astrophysics. While the exact nature of dark matter remains unknown, its presence is essential for understanding the formation and evolution of galaxies. NGC 6744, with its well-defined spiral structure and relatively stable motion, provides an ideal laboratory for studying the interplay between visible matter and dark matter. By analyzing the distribution of stars, gas, and dark matter in NGC 6744, scientists can refine their models of galactic formation and test theories about the nature of dark matter. Another fascinating aspect of NGC 6744 is its interaction with the broader cosmic web. As mentioned earlier, galaxies are not isolated entities but are part of a larger structure that spans the universe. The cosmic web is a vast network of galaxies, dark matter, and gas, and NGC 6744 is a small, albeit significant, part of this grand structure. The distribution of galaxies in the cosmic web is influenced by the expansion of the universe, with galaxies being drawn toward each other due to their mutual gravitational attraction. While NGC 6744 is relatively isolated in the local universe, it is still part of this larger cosmic network. The study of galaxies like NGC 6744 in the context of the cosmic web helps scientists understand how large-scale structures form and evolve over time. It also provides important insights into the forces that shape the universe on the largest scales. NGC 6744, with its relatively undisturbed structure and active star formation, serves as an excellent example of how galaxies evolve within this cosmic framework. To further explore the complexities of NGC 6744, astronomers rely on a range of observational techniques, including optical, infrared, and radio telescopes. Each of these methods provides a different perspective on the galaxy, revealing different aspects of its structure and activity. For instance, optical telescopes allow astronomers to study the visible light emitted by stars, while infrared telescopes are able to detect the heat emitted by dust and gas. Radio telescopes, on the other hand, can detect emissions from neutral hydrogen gas, which is a key component of the galaxy's interstellar medium. By combining data from different wavelengths, scientists can create a more complete picture of NGC 6744's structure and dynamics. This multi-wavelength approach is essential for studying galaxies in detail, as different wavelengths reveal different components of the galaxy. For example, infrared observations can highlight regions of active star formation that may be obscured by dust in optical images. Similarly, radio observations can uncover large-scale gas structures that are not visible in other wavelengths. In the case of NGC 6744, recent studies using the Hubble Space Telescope have provided stunning, high-resolution images of the galaxy's spiral arms and central region. These images have revealed new details about the structure of the galaxy's disk and bulge, as well as the distribution of star-forming regions. The Hubble data has also been instrumental in identifying the positions of individual stars, helping scientists better understand the age and composition of the galaxy's stellar populations. Another important tool in the study of NGC 6744 is the study of its kinematics, or the motion of stars and gas within the galaxy. By measuring the velocity of stars and gas in different parts of the galaxy, astronomers can infer the distribution of mass within NGC 6744, including the presence of dark matter. This information is crucial for understanding the forces that govern the galaxy's evolution and structure. Additionally, studying the motion of gas can provide insights into the processes driving star formation, as well as the influence of the central supermassive black hole on the galaxy's dynamics. The study of the kinematics of galaxies like NGC 6744 is not only valuable for understanding the galaxy itself but also for making broader inferences about the general processes that govern galaxy formation and evolution. For example, by measuring the rotation curves of galaxies like NGC 6744, astronomers can estimate the amount of dark matter present. In many spiral galaxies, including NGC 6744, the rotation curve, the relationship between the distance from the galactic center and the speed at which stars and gas move, remains flat at large distances from the center, indicating the presence of unseen mass. This is the telltale signature of dark matter, which, though invisible, exerts a gravitational pull on visible matter. As mentioned earlier, dark matter is believed to form a vast halo around galaxies like NGC 6744, extending well beyond the visible stars and gas. This dark matter halo is crucial in stabilizing the galaxy, preventing it from falling apart as a result of the forces exerted by the galaxy's rotation. Without the gravitational influence of dark matter, the visible matter in NGC 6744 would not be able to maintain the galaxy's structure, particularly in the outer reaches. In this sense, dark matter plays an essential role in the overall dynamics of the galaxy, shaping its formation and evolution over billions of years. The mass distribution within NGC 6744, including the contributions from both visible and dark matter, has been studied in detail through various methods, including gravitational lensing and galaxy rotation curves. Gravitational lensing, a phenomenon in which light from background objects is bent by the gravitational field of a massive object like a galaxy, provides valuable information about the mass distribution of NGC 6744. By studying the way light is distorted as it passes through the galaxy, astronomers can map out the galaxy's mass profile, including the extent of its dark matter halo. These techniques, along with others such as X-ray observations and optical spectroscopy, provide a comprehensive view of the internal structure of NGC 6744. By combining this data, astronomers can build detailed models of the galaxy's mass distribution and understand how it has evolved over time. This process is not only valuable for NGC 6744 but also for understanding the broader mechanisms that govern galaxy formation in the universe. Interestingly, the mass distribution of NGC 6744 appears to be relatively well-behaved compared to other galaxies, which can have more complex or irregular mass profiles due to recent interactions, mergers, or tidal disruptions. The relatively calm nature of NGC 6744's structure suggests that it has not experienced significant external forces that might have altered its shape or mass distribution. This stability allows for a more accurate study of the processes that have shaped the galaxy's evolution over time, including the role of dark matter in its development. Another significant aspect of NGC 6744's environment is its location within the broader universe. The galaxy is part of the so-called local universe, a region that includes a variety of galaxies, some isolated and some in clusters. NGC 6744 resides in a relatively sparse part of the universe, with few neighboring galaxies close enough to exert significant tidal forces on it. This relative isolation has likely contributed to its well-preserved spiral structure, as it has been free from the disruptive effects of galaxy mergers or interactions that often distort the shapes and dynamics of galaxies. Despite its isolation, NGC 6744 is still part of a vast cosmic network, and its position in the universe provides valuable insights into the large-scale structure of the cosmos. The Galaxies study helps astronomers better understand how galaxies are distributed throughout the universe and how they evolve in different environments. Some galaxies in denser regions, such as those in galaxy clusters, may experience more frequent interactions and mergers, which can lead to more irregular structures. In contrast, galaxies like NGC 6744, located in more sparsely populated regions, are more likely to maintain their original spiral shapes and experience slower, more gradual evolutionary changes. One particularly intriguing aspect of NGC 6744's environment is the potential for future interactions with other galaxies. While the galaxy appears to be relatively isolated at present, it is possible that in the distant future, NGC 6744 could interact with other nearby galaxies. The gravitational forces from a passing galaxy could distort NGC 6744's spiral arms, trigger new bursts of star formation, or even result in a merger. The fate of galaxies like NGC 6744 in the context of the broader universe is a topic of great interest to astronomers, as it sheds light on the dynamic and ever-changing nature of the cosmos. Galactic interactions and mergers are some of the most dramatic events in the universe, often leading to the formation of elliptical galaxies and triggering intense periods of star formation. However, the potential for such interactions depends on the relative velocities and trajectories of galaxies. If NGC 6744 were to collide with another galaxy, the resulting forces would likely have profound effects on its structure and star formation rate. The gravitational interaction could lead to the redistribution of gas and stars, potentially triggering a new phase in the galaxy's evolution. In the broader context of galactic mergers, NGC 6744 could eventually play a role in the formation of a larger, more massive galaxy. This process, known as galaxy assembly, is believed to be a key driver of galaxy evolution in the universe. Through mergers and accretion, smaller galaxies like NGC 6744 can contribute to the growth of more massive galaxies, which can then exert greater influence on the surrounding cosmic environment. The study of NGC 6744 and its potential for future interactions highlights the dynamic nature of the universe. While the galaxy may seem isolated at the moment, its future is far from set in stone. The ongoing processes of star formation, the influence of dark matter, and the potential for galactic interactions all contribute to the ever-evolving story of NGC 6744. For now, NGC 6744 remains a striking example of a large, well-ordered spiral galaxy, with its intricate spiral arms, star-forming regions, and stable central bulge. The galaxy provides an invaluable opportunity for astronomers to study the interplay of various forces, from the gravitational influence of dark matter to the energetic processes at work in its star-forming regions. As observational techniques continue to improve, the detailed study of NGC 6744 will undoubtedly yield even more insights into the processes that govern galaxy formation and evolution. Ultimately, the story of NGC 6744 is part of the larger narrative of the universe itself, a story of galaxies, stars, gas, and dark matter, all interacting and evolving over vast timescales. The study of this galaxy offers a window into the complexities of the cosmos, shedding light on the processes that have shaped the universe from its earliest moments to its current state. As we continue to explore the universe, NGC 6744 will remain an important object of study, helping to unravel the mysteries of galaxy formation, dark matter, and the intricate dynamics of the universe. As astronomers continue to explore the depths of space, our understanding of galaxies like NGC 6744 continues to evolve. The pursuit of knowledge about these cosmic objects not only enhances our grasp of galaxy formation and evolution but also provides a broader framework for understanding the universe's origins and ultimate fate. The observation of NGC 6744 offers critical insights into the interplay between visible and invisible forces, such as the complex relationship between ordinary matter, and dark energy. One of the most remarkable aspects of studying NGC 6744 lies in its visual resemblance to the Milky Way, our home galaxy. Both galaxies share similar characteristics, including a prominent central bulge, a well-defined disk, and vast spiral arms. This resemblance suggests that NGC 6744 may represent a more mature stage of galactic evolution, offering a glimpse into the future of the Milky Way. Just as our galaxy is likely to undergo dramatic changes over the course of billions of years, due to mergers, internal dynamics, and the slow accretion of material, so too will NGC 6744. Thus, studying this galaxy allows us to speculate about our own galaxy's future and how it will evolve in the grand cosmic timeline. It's important to highlight how the continued development of observational technologies has significantly advanced our knowledge of galaxies like NGC 6744. From the early days of astronomical observation through simple telescopes, the detail with which we can now observe distant galaxies has increased dramatically. Instruments like the Hubble Space Telescope and the Atacama Large Millimeter/Submillimeter Array, ALMA, have revolutionized our ability to study galaxies in unprecedented detail, providing not only images of their structures but also allowing us to analyze their composition, velocity, and interactions with their surroundings. With these advancements, our understanding of spiral galaxies like NGC 6744 has also grown. The images captured by Hubble's advanced optical capabilities show the galaxy in stunning detail, revealing the fine structures of its spiral arms, the dense star-forming regions, and the faint, far-reaching tendrils of its halo. Additionally, ALMA's observations in the radio and submillimeter wavelengths provide a different perspective, uncovering the cool gas and dust that populate the galaxy's outer regions. These insights help scientists better understand the interplay between the stars, gas, dust, and dark matter that constitute galaxies. Moreover, the growing power of computer simulations and modeling has allowed scientists to simulate the formation and evolution of galaxies in ways that were previously unimaginable. By inputting detailed data from observational instruments into these simulations, astronomers can create models that predict how galaxies like NGC 6744 evolve over time. These simulations take into account the complex forces at play, such as gravitational interactions, star formation, supernova feedback, and the influence of dark matter, and allows scientists to test hypotheses about the galaxy's past and future. These models not only help us understand NGC 6744 in isolation but also provide a framework for comparing it with other galaxies in the universe, leading to a more comprehensive understanding of the diversity of galactic types and behaviors. One of the most exciting aspects of studying galaxies like NGC 6744 is the potential to observe phenomena that occur on galactic scales, which can have profound implications for our understanding of fundamental physics. For instance, the central black hole in NGC 6744, though not yet fully studied, may provide vital clues about the role of supermassive black holes in galaxy evolution. Supermassive black holes are believed to reside at the centers of nearly all large galaxies, and their growth is thought to be closely tied to the overall evolution of the host galaxy. In some cases, the growth of the black hole may be synchronized with the rate of star formation in the galaxy, while in others, the feedback from the black hole could suppress star formation by expelling vast amounts of energy into the surrounding gas. Although NGC 6744's central black hole is not yet as extensively studied as those in other galaxies, its properties could offer valuable insights into the feedback processes that govern galaxy evolution. By studying the radiation emitted by the black hole, particularly in the form of X-rays, astronomers can gain a better understanding of the conditions near the event horizon, the boundary beyond which not even light can escape. These observations help us piece together the complex dynamics of supermassive black holes and their impact on their host galaxies. The study of NGC 6744 and other galaxies also plays a key role in the quest to understand the large-scale structure of the universe. The universe is not a uniform and smooth expanse but instead is structured on vast scales, with galaxies distributed in intricate patterns. NGC 6744 is part of this cosmic web, a network of galaxies that is shaped by the gravitational influence of dark matter. By observing the positions and movements of galaxies like NGC 6744, scientists can gain insights into the nature of dark matter, its role in shaping the structure of the universe, and how it has influenced the distribution of galaxies over cosmic time. Additionally, the study of galaxies like NGC 6744 contributes to our understanding of galaxy clusters, the largest gravitationally bound structures in the universe. While NGC 6744 itself is not part of a galaxy cluster, it is situated within a region of the universe where galaxies are relatively isolated, providing a valuable contrast to the denser environments found in clusters. Galaxies and clusters often experience different evolutionary paths compared to those in more isolated regions, with interactions between galaxies being more frequent and mergers being more common. These differences can lead to the formation of giant elliptical galaxies, the depletion of gas that would otherwise form stars, and the disruption of spiral structures. In this broader cosmic context, NGC 6744 provides a snapshot of a galaxy that has evolved relatively independently, free from the major disruptive forces that occur in denser environments. The relatively undisturbed nature of NGC 6744 makes it an excellent laboratory for studying the long-term evolution of spiral galaxies and for testing theories about galaxy formation and dark matter. The study of NGC 6744 also raises philosophical questions about our place in the universe. As we peer deeper into space and observe galaxies billions of light-years away, we are confronted with the vastness of the cosmos. The sheer scale of these objects, their age, their size, and the processes that govern their evolution, forces us to reconsider our understanding of time, space, and the fundamental laws of physics. NGC 6744, with its vast spiral arms and intricate structure, is a reminder of the intricate web of galaxies that make up the universe, a universe that continues to evolve, just as our understanding of it continues to grow. The future study of NGC 6744 will undoubtedly reveal even more about the forces that govern galaxy evolution and the large-scale structure of the universe. New observational technologies, coupled with the continued development of sophisticated computer models, will allow scientists to probe deeper into the mysteries of galaxies like NGC 6744. As our knowledge of the cosmos expands, NGC 6744 will remain a key object of study, helping to unravel the complex and awe-inspiring story of the universe's past, present, and future. As we continue to explore the fascinating complexities of NGC 6744, it's important to consider the potential for further discoveries in the coming years. With each advancement in telescope technology, new and more detailed observations can be made, potentially unveiling phenomena that were previously undetectable. For instance, upcoming space missions and observatories, such as the James Webb Space Telescope, JWST, could provide invaluable insights into the composition, star formation rates, and internal dynamics of galaxies like NGC 6744. The JWST's ability to observe the universe in infrared light opens up new possibilities, as this range of wavelengths can penetrate through dust and gas, revealing areas that optical telescopes might miss. This could allow for an even more detailed study of NGC 6744's central regions and spiral arms. Another significant area of future research involves the study of the interstellar medium, ISM, within NGC 6744. The ISM refers to the gas and dust that exists between stars within a galaxy, and it plays a crucial role in the process of star formation. In galaxies like NGC 6744, the ISM is rich in molecular clouds, dense regions of gas that can collapse under gravity to form new stars. Understanding the properties of the ISM in NGC 6744, such as its composition, temperature, and density, is essential for understanding the mechanisms of star formation and how they may differ between various types of galaxies. Recent observations have suggested that NGC 6744 may have an active star-forming region within its spiral arms, where the density of gas is higher and star formation is most likely to occur. These star-forming regions are often associated with bright blue regions of the galaxy, where newly formed, massive stars illuminate the surrounding gas. As these stars age and eventually die, they contribute to the enrichment of the galaxy's ISM by dispersing heavy elements into space through supernovae or stellar winds. This process is part of the ongoing cycle of matter within galaxies, where elements like carbon, oxygen, and iron are constantly being recycled and incorporated into new stars, planets, and even life forms. The study of this stellar recycling process within NGC 6744 could provide insights into the galaxy's evolution and its ability to sustain new generations of stars. In addition to star formation, the role of cosmic ray particles in NGC 6744 is another area of interest for researchers. Cosmic rays are high-energy particles, primarily protons, that travel through space at nearly the speed of light. These particles are produced by a variety of processes, including supernova explosions, active galactic nuclei, and interactions between high-energy particles and magnetic fields. As cosmic rays interact with the ISM, they can induce reactions that produce secondary particles, such as gamma rays. By studying the distribution of cosmic rays in NGC 6744, astronomers can gain insights into the energetic processes that shape the galaxy's evolution. Additionally, cosmic rays may have an influence on star formation rates, as they can heat the surrounding gas and prevent it from collapsing into new stars. One of the more speculative yet intriguing aspects of future research on NGC 6744 involves the possibility of detecting extraterrestrial life in its outer regions. Although the likelihood of finding life in a galaxy so distant is small, the study of distant galaxies like NGC 6744 provides valuable context for the search for life beyond Earth. The more we understand about the conditions necessary for life to arise, such as the presence of liquid water, organic molecules, and stable star systems, the better we can assess the potential for habitable environments in other parts of the universe. In particular, the study of exoplanets within galaxies like NGC 6744 could shed light on the prevalence of planets that are conducive to the development of life. While the possibility of discovering alien life in a galaxy so far away might seem remote, the search for biosignatures on exoplanets remains a compelling avenue of research. In the future, astronomers may be able to detect the faint glow of exoplanets in NGC 6744 using next-generation telescopes capable of studying planetary atmospheres. This could open up new opportunities for understanding the factors that make a planet habitable and the likelihood of finding life in galaxies beyond our own. As technology continues to improve, we may also be able to study the effects of gravitational waves on galaxies like NGC 6744. Gravitational waves are ripples in spacetime caused by the acceleration of massive objects, such as merging black holes or neutron stars. These waves propagate through the universe at the speed of light, and their detection could provide a wealth of information about the most extreme events in the cosmos. The study of gravitational waves could help us understand the fundamental nature of space and time and shed light on the interactions between galaxies, black holes, and other exotic objects in NGC 6744. In addition to the study of gravitational waves, another exciting prospect for the future of NGC 6744 research is the potential discovery of new and exotic objects, such as rogue planets or dark matter structures. Rogue planets are planets that do not orbit stars and instead wander through space, potentially existing in the outer reaches of galaxies like NGC 6744. These objects are difficult to detect due to their lack of a light source, but recent advancements in infrared and radio astronomy may make it possible to observe them. Understanding the presence and distribution of rogue planets could have significant implications for our understanding of planetary formation and the dynamics of galaxies. Dark matter, which makes up a significant portion of the mass of galaxies but does not interact with light in any detectable way, remains one of the greatest mysteries of modern astrophysics. The study of galaxies like NGC 6744 is crucial for understanding the role that dark matter plays in the formation and behavior of galaxies. Recent observations suggest that dark matter may be concentrated in large halos surrounding galaxies, influencing their rotation and the motion of stars and gas within them. By studying the rotation curves of galaxies like NGC 6744, astronomers can infer the distribution of dark matter and gain a deeper understanding of its properties. As we continue to investigate NGC 6744 and other galaxies, we may also gain a better understanding of the broader cosmic processes that shape the universe. The study of galaxy mergers, for instance, could provide insight into how galaxies like NGC 6744 will evolve in the future. In some cases, galaxies collide and merge to form larger, more massive galaxies. These mergers can trigger bursts of star formation and lead to the creation of new structures within the galaxy, such as elliptical galaxies or active galactic nuclei. Understanding these processes is crucial for predicting the future evolution of NGC 6744 and other galaxies in our cosmic neighborhood. Moreover, the study of galaxy clusters, in which galaxies are bound together by gravity, could help us understand the large-scale structure of the universe. NGC 6744 is part of the greater cosmic web of galaxies, and its place in this network provides important clues about the evolution of the universe as a whole. By mapping the distribution of galaxies in the cosmic web, astronomers can gain insights into the nature of dark matter and dark energy, the two mysterious forces that dominate the universe's expansion. As our knowledge of galaxies like NGC 6744 continues to expand, we are reminded of the profound mysteries that remain in the universe. From the formation of stars to the behavior of dark matter, from the potential for extraterrestrial life to the study of gravitational waves, NGC 6744 stands as a symbol of the infinite possibilities for discovery that lie ahead. The more we learn about this distant galaxy, the more we realize how much we still have to uncover about the cosmos. Our exploration of NGC 6744 is far from over, and as our tools and technologies improve, so too will our understanding of this majestic spiral galaxy. As our exploration of NGC 6744 deepens, it's essential to consider how the study of this galaxy fits within the broader context of our understanding of the universe. NGC 6744 is not just an isolated object but a representation of a category of galaxies, spiral galaxies, that are among the most common and fascinating structures in the cosmos. By studying galaxies like NGC 6744, astronomers gain insights not only into the specific properties of this galaxy but also into the processes that govern the behavior of galaxies as a whole. The study of spiral galaxies is crucial for understanding the formation and evolution of galaxies. Spiral galaxies like NGC 6744 are often thought to have formed through a process of gradual accretion of gas and dust, which eventually condensed to form stars and other structures. Over billions of years, these galaxies have evolved into their current state, with their distinctive spiral arms and central bulges. By understanding how NGC 6744 fits into this process, we can learn more about the conditions that lead to the formation of galaxies and how they evolve over time. One of the key factors influencing the evolution of spiral galaxies is the availability of gas and dust, which serve as the raw materials for star formation. In galaxies like NGC 6744, the interstellar medium, ISEM, plays a vital role in regulating the rate of star formation. As gas and dust collapse under gravity to form new stars, they release energy in the form of radiation and wind. This energy can then interact with the surrounding gas, creating complex feedback loops that influence the galaxy's star formation rate. Understanding these interactions is crucial for understanding the lifecycle of galaxies, as the rate of star formation ultimately determines the long-term evolution of a galaxy. One of the most striking features of NGC 6744 is its large, well-defined spiral arms, which are rich in young, hot stars. These spiral arms are regions of high gas density, where new stars are born in vast stellar nurseries. As these stars age and die, they enrich the surrounding gas with heavy elements, which are then incorporated into the formation of new stars. This cycle of stellar birth and death is a fundamental process that shapes the evolution of spiral galaxies. By studying the star formation activity in NGC 6744, astronomers can gain valuable insights into the star formation history of the galaxy and how it compares to other spiral galaxies in the universe. NGC 6744 is also a prime candidate for studying the role of supernovae in the evolution of galaxies. Supernovae, the explosive deaths of massive stars, play a critical role in enriching the interstellar medium with heavy elements like iron, carbon, and oxygen. These elements are essential for the formation of planets, as well as for the development of life as we know it. Supernovae also release large amounts of energy into the surrounding gas, which can trigger the formation of new stars or, conversely, disrupt the star-forming process by heating up the gas and preventing it from collapsing. The study of supernovae in NGC 6744 provides important clues about the interplay between stellar evolution, gas dynamics, and star formation. Moreover, NGC 6744's proximity to the Milky Way galaxy allows for comparative studies that enhance our understanding of both galaxies. While the Milky Way is a massive spiral galaxy with a rich history of star formation and cosmic events, NGC 6744 offers a snapshot of a similar galaxy at a different stage in its evolution. By comparing the two, astronomers can identify similarities and differences that help them understand the broader patterns of galaxy formation and evolution. For example, NGC 6744 may provide clues about the early stages of spiral galaxy formation, as well as insights into the long-term evolution of these galaxies. One of the most compelling aspects of NGC 6744 is its central bulge, a region of tightly packed stars at the heart of the galaxy. The bulge of a spiral galaxy like NGC 6744 is thought to be the remnant of an earlier phase in the galaxy's evolution, during which the galaxy's central regions were dominated by older stars. Over time, the bulge has been shaped by the dynamics of the galaxy's disk, and it now serves as a key feature of the galaxy's overall structure. The study of the central bulge in NGC 6744 could provide valuable insights into the processes that shape the formation of bulges in spiral galaxies. These processes may involve the interaction of the galaxy's disk with its central supermassive black hole, as well as the effects of galaxy mergers and accretion. As we examine the more intricate aspects of NGC 6744, the role of dark matter becomes an important consideration. Dark matter is a mysterious substance that does not emit or interact with light, making it invisible to traditional telescopes. However, its presence can be inferred by its gravitational effects on visible matter. In the case of NGC 6744, dark matter is thought to be concentrated in a large halo that surrounds the galaxy. This dark matter halo exerts a gravitational influence on the galaxy's stars and gas, affecting their motion and rotation. By studying the rotation curve of NGC 6744, astronomers can map out the distribution of dark matter and learn more about its properties. The distribution of dark matter in NGC 6744 is of particular interest because it may offer insights into the overall structure of the universe. Dark matter is thought to make up about 27% of the universe's total mass, and its gravitational effects are crucial for the formation and stability of galaxies. By studying dark matter in galaxies like NGC 6744, astronomers hope to better understand its role in the evolution of galaxies and the large-scale structure of the universe. Another fascinating aspect of NGC 6744 is its interaction with its environment. Like many galaxies, NGC 6744 is part of a larger cosmic web of galaxies that are interconnected by vast cosmic filaments of dark matter and gas. These filaments form the large-scale structure of the universe and influence the behavior of galaxies. NGC 6744's position within this structure may have implications for its evolution, as gravitational interactions with neighboring galaxies could influence its star formation activity, its rotation curve, and even its eventual fate. For example, NGC 6744 may be influenced by tidal forces from nearby galaxies, which could distort its shape or trigger bursts of star formation. As our ability to observe distant galaxies continues to improve, we will undoubtedly gain new insights into the processes that govern galaxies like NGC 6744. The next generation of space telescopes, such as the James Webb Space Telescope and the next generation radio telescopes, will provide unprecedented resolution and sensitivity, allowing us to study galaxies like NGC 6744 in even greater detail. With these new tools, we may be able to uncover hidden features of the galaxy, such as faint regions of star formation, the structure of its dark matter halo, and the nature of its central black hole. These discoveries will undoubtedly enhance our understanding of NGC 6744 and contribute to our broader knowledge of the universe. In addition to the technical advancements, future discoveries about NGC 6744 could also have profound implications for our understanding of the cosmos as a whole. As we continue to study this distant galaxy, we are reminded of the vastness of the universe and the myriad mysteries that still remain. Each new discovery, whether it be about the behavior of stars, the nature of dark matter, or the potential for life elsewhere in the galaxy, brings us closer to answering some of the most fundamental questions about the universe. As we look to the future of NGC 6744 research, it is clear that there is still much to learn. From the star-forming regions within its spiral arms to the dark matter halo that surrounds it, this galaxy offers a wealth of scientific opportunities. As technology continues to improve, we can expect even more groundbreaking discoveries in the coming years. The study of NGC 6744, and galaxies like it, will remain a cornerstone of modern astronomy, helping to unlock the secrets of the universe one discovery at a time. As we continue our journey into the depths of NGC 6744, it's important to consider how the discoveries made in this galaxy can be applied to understanding other galaxies in the universe. The significance of NGC 6744 goes beyond its beauty and complexity. It serves as a cosmic laboratory where astronomers can test hypotheses and refine models that help us understand how galaxies, including our own, evolve over time. One of the most intriguing aspects of NGC 6744 is its relatively similar structure to our own Milky Way galaxy. In many ways, NGC 6744 acts as a stand-in for what the Milky Way might have looked like billions of years ago, before the intense gravitational interactions and star formation activity we see today. Studying NGC 6744 allows scientists to model the early evolution of spiral galaxies and understand how our own galaxy may have formed and developed over time. With its well-defined spiral arms, central bulge, and abundant star-forming regions, NGC 6744 provides a snapshot of a galaxy in its prime, offering clues about the processes that govern galaxy evolution. The Milky Way, as a barred spiral galaxy, shares many features with NGC 6744, despite some structural differences. Both galaxies contain large central bulges made up of older stars, as well as spiral arms rich in young, hot stars. The Milky Way's barred structure, however, is absent in NGC 6744, which makes this galaxy an interesting contrast. By examining the differences between the two, astronomers can learn more about the factors that determine whether a spiral galaxy will develop a bar structure, as well as the implications this might have on the galaxy's star formation activity and overall evolution. One of the key differences between the Milky Way and NGC 6744 lies in their environments. The Milky Way is part of the local group of galaxies, a collection of more than 50 galaxies, including the Andromeda Galaxy. NGC 6744, on the other hand, resides in a more isolated environment, which gives it a unique evolutionary path. The presence of neighboring galaxies can have a profound impact on the formation and evolution of galaxies, influencing their star formation rates, structure, and even their fate. By comparing NGC 6744's isolated environment with the more crowded environment of the Milky Way, scientists can gain a better understanding of how environmental factors shape the development of galaxies. While NGC 6744 is a relatively isolated galaxy, it is not completely immune to the effects of its environment. The galaxy resides in the outskirts of a larger cosmic structure known as the Great Wall. a vast network of galaxies and galaxy clusters that form a part of the larger-scale structure of the universe. The Great Wall is one of the largest known structures in the cosmos, spanning hundreds of millions of light-years. As part of this structure, NGC 6744 is subject to the gravitational influences of other galaxies and galaxy clusters in the region, which can affect its motion and the distribution of its stars and gas. These interactions could play a role in the galaxy's ongoing evolution, potentially influencing its star formation activity, the stability of its spiral arms, and even its long-term fate. One of the most significant contributions of studying NGC 6744 lies in its potential to help astronomers understand the role of galaxy mergers in shaping the structure and evolution of galaxies. Galaxies like NGC 6744 are thought to have formed through a combination of gradual accretion of gas and dust and the occasional merger with smaller galaxies. While NGC 6744 itself does not appear to be undergoing a major merger at present, its structure may have been shaped by past interactions with smaller galaxies. These past mergers could have played a role in the formation of the galaxy's spiral arms, central bulge, and overall dynamics. Understanding how these mergers influence the evolution of spiral galaxies will help astronomers predict the future of galaxies like NGC 6744 and our own Milky Way. Mergers between galaxies are an important part of the life cycle of galaxies. While smaller galaxies can be torn apart by the gravitational forces of larger galaxies like NGC 6744 can often survive these encounters and even grow more massive as a result. The Milky Way itself is on a collision course with the Andromeda Galaxy, and scientists predict that in about 4 billion years, the two galaxies will merge to form a larger elliptical galaxy. Studying galaxies like NGC 6744 can provide valuable insights into the dynamics of galaxy mergers, including the role of dark matter, gas flows, and star formation during these cosmic collisions. While galaxy mergers are important for the evolution of galaxies, they are not the only process that influences a galaxy's development. For example, the presence of supermassive black holes at the centers of galaxies is thought to play a crucial role in the evolution of galaxies. These black holes can influence the surrounding gas and stars through their gravitational pull and the energy released during the accretion of material onto the black hole. NGC 6744 is believed to have a supermassive black hole at its center, although the exact properties of this black hole remain uncertain. Studying the behavior of the supermassive black hole in NGC 6744, as well as the role it plays in the galaxy's evolution, could provide important clues about the relationship between black holes and their host galaxies. In addition to the study of galaxy mergers and supermassive black holes, NGC 6744 offers an opportunity to examine the impact of other galactic phenomena, such as cosmic rays and magnetic fields. Cosmic rays are high-energy particles that travel through space and interact with the gas and dust in galaxies. These particles can affect the rate of star formation and the dynamics of the interstellar medium, influencing the overall evolution of the galaxy. Magnetic fields also play a role in the evolution of galaxies, shaping the behavior of the interstellar medium and influencing the formation of stars and other structures. The study of cosmic rays and magnetic fields in NGC 6744 could provide valuable insights into the broader processes that govern the behavior of galaxies. As we move forward into the future, the study of NGC 6744 will continue to offer new opportunities for discovery. With advancements in technology and new observations from next-generation telescopes, astronomers will be able to observe the galaxy in greater detail than ever before. These observations may lead to new insights into the fundamental processes that govern the evolution of galaxies, from the role of dark matter and black holes to the interactions between galaxies and their environments. It is clear that this galaxy is more than just a distant object in the sky. It is a key piece of the cosmic puzzle that helps us understand the formation and evolution of galaxies across the universe. The study of NGC 6744, and galaxies like it, has profound implications for our understanding of the cosmos and our place within it. By studying the intricate details of this beautiful spiral galaxy, we can unlock the secrets of the universe and gain a deeper understanding of the forces that shape the cosmos. The study of galaxies like NGC 6744 also raises important questions about the larger-scale structure of the universe. As we look deeper into the cosmos, we are confronted with the vast interconnectedness of galaxies, galaxy clusters, and superclusters. NGC 6744, with its impressive size and structural complexity, represents a small but significant piece of the puzzle that is the large-scale structure of the universe. Its position on the outskirts of the Great Wall, one of the largest known structures in the cosmos, serves as a reminder that even galaxies that appear isolated are influenced by the gravitational forces of their surroundings. One of the major scientific challenges when studying galaxies like NGC 6744 is understanding how galaxies are distributed across the universe. The universe is not a random collection of galaxies, but rather a highly structured entity, with galaxies forming intricate webs of matter that span vast distances. These large-scale structures, including clusters and superclusters, are the result of the expansion of the universe and the gravitational attraction between galaxies. NGC 6744, by residing in the outskirts of the Great Wall, provides valuable insights into the role of cosmic structures in shaping the evolution of galaxies. The presence of large cosmic structures, such as the Great Wall, suggests that the universe's expansion is not uniform, but rather influenced by the gravitational pull of massive structures. This uneven distribution of matter is responsible for the formation of cosmic voids, where galaxies are few and far between, and dense regions, where galaxies are packed closely together. The study of galaxies like NGC 6744, positioned on the fringes of these large-scale structures, allows astronomers to investigate the impact of these gravitational forces on the formation and evolution of galaxies. To further understand NGC 6744's place within the larger context of the universe, we must consider its future and the forces that will shape its destiny. The cosmic future of NGC 6744 will be influenced by both its internal dynamics and its interactions with nearby galaxies. As mentioned earlier, galaxy mergers are a common occurrence in the universe, and NGC 6744 is not immune to these processes. While NGC 6744 is not currently involved in any major mergers, its future may see it collide with smaller galaxies or other objects in the universe. These interactions will likely trigger bursts of star formation, change the shape of the galaxy, and potentially lead to the formation of new structures within NGC 6744. In addition to galaxy mergers, the fate of NGC 6744 may also be influenced by the behavior of its supermassive black hole. The supermassive black hole at the center of the galaxy plays a crucial role in its evolution. As material falls into the black hole, energy is released in the form of radiation, which can heat up the surrounding gas and influence star formation in the galaxy. In some cases, supermassive black holes can expel large amounts of material in powerful jets, which can have a profound impact on the surrounding interstellar medium. These jets can disrupt star formation, prevent the accumulation of gas, and change the dynamics of the galaxy as a whole. The long-term behavior of NGC 6744's black hole will play a critical role in shaping the galaxy's future, and by studying the black hole's activity, astronomers can gain insights into the mechanisms that govern the evolution of galaxies. Looking even further into the future, the ultimate fate of NGC 6744 could be tied to the larger-scale dynamics of the universe itself. The expansion of the universe is a key factor in determining the future of galaxies, and the rate of this expansion has been a subject of intense study in recent years. Observations of distant galaxies have shown that the expansion of the universe is accelerating, driven by a mysterious force known as dark energy. This acceleration means that galaxies are moving away from one another at an ever-increasing rate, and as a result, distant galaxies will eventually become unreachable. Over time, the gravitational influence of the Great Wall and other large-scale structures may not be enough to counteract the expansion of the universe, leading to a gradual isolation of galaxies like NGC 6744 from the rest of the cosmos. This process, which will take billions of years, is known as the Great Isolation, and will result in galaxies being separated by vast, ever-expanding voids of space. While the Great Isolation is a distant future event, it highlights the fragility of galaxies in the grand scale of the universe. The study of NGC 6744 and other galaxies gives us a glimpse into the eventual fate of all galaxies, including our own Milky Way. As the universe continues to expand, galaxies will become increasingly isolated, and the interactions that shape their evolution will become less frequent. In the long run, galaxies like NGC 6744 may eventually fade into the dark recesses of space, their stars burning out one by one as the cosmic forces that once shaped them dissipate. The study of NGC 6744, however, does not just offer a glimpse into the future of the galaxy itself. It also provides insights into the fundamental processes that govern the behavior of galaxies across the universe. The interactions between galaxies, the role of supermassive black holes, and the influence of large-scale structures all contribute to the evolution of galaxies, shaping their appearance, behavior, and fate. By studying NGC 6744, astronomers can learn more about the forces that drive the formation and evolution of galaxies, and by extension, the universe itself. One of the most exciting aspects of studying NGC 6744 is the possibility of uncovering new and unexpected phenomena. The universe is vast and full of mysteries, and even well-studied objects like NGC 6744 can hold surprises. New technologies, such as the James Webb Space Telescope and the upcoming Extremely Large Telescope, are opening up new frontiers in our understanding of the universe. These advanced telescopes will allow astronomers to study galaxies like NGC 6744 in unprecedented detail, revealing new information about the galaxy's structure, star formation activity, and dark matter content. As we continue to explore NGC 6744, it is important to remember that this galaxy is just one example of the incredible diversity of galaxies that populate the universe. Every galaxy, from the smallest dwarf galaxies to the largest supermassive galaxies, has its own unique story to tell. By studying NGC 6744 and other galaxies, we gain valuable insights into the nature of the universe, the forces that shape it, and our place within it. The more we learn about galaxies like NGC 6744, the closer we come to understanding the fundamental workings of the cosmos. NGC 6744 is much more than just another galaxy in the night sky. It is a cosmic jewel that provides a wealth of information about the processes that govern the formation, evolution, and fate of galaxies. Its striking spiral arms, star-forming regions, and potential for future interactions with other galaxies make it a fascinating object of study for astronomers. Through the lens of NGC 6744, we gain a deeper understanding of the universe's grand design, and with every observation, we come closer to unlocking the mysteries of the cosmos. As we delve further into the mystery of NGC 6744, one cannot ignore the role that the galaxy's morphology plays in understanding the broader structure of galaxies in the universe. The spiral galaxy is often considered a textbook example of what a typical large galaxy might look like, but the deeper we look, the more complex and fascinating its structure becomes. As astronomers study NGC 6744, it becomes clear that it offers an ideal model for understanding not only the evolution of individual galaxies, but also the forces that shape them over cosmic time. The spiral arms of NGC 6744 are not just beautiful visual features, but they are rich with information about the processes occurring within the galaxy. These spiral arms are often sites of intense star formation, where the gravitational collapse of gas clouds creates new stars. NGC's 6744 spiral arms are particularly striking due to their well-defined, sweeping structure. This defined shape is a result of the way in which material within the galaxy responds to the gravitational forces of the galaxy's central bulge and its dark matter halo. The pattern of the spiral arms can be thought of as a wave that propagates through the disk of the galaxy, compressing gas and dust as it moves, thus triggering the formation of new stars. What makes NGC 6744 even more intriguing is its high surface brightness, meaning that it is particularly luminous in visible light. This luminosity comes from the billions of stars that make up the galaxy, many of which are concentrated in its dense core. The central region of NGC 6744 is home to a large concentration of older stars, and at the heart of the galaxy lies a supermassive black hole. While this black hole is relatively quiet compared to those in other galaxies, its mere presence raises fascinating questions about the role black holes play in shaping the life cycle of galaxies. In addition to the star-forming regions, the central bulge of NGC 6744 contains a mix of older stars, and its structure provides valuable clues about the galaxy's history. The bulge itself is thought to have formed early in the galaxy's evolution, with stars in this region having a much older age compared to those in the spiral arms. These older stars in the bulge represent a different phase in the galaxy's development. As we explore this region, we begin to appreciate how NGC 6744, like all galaxies, has undergone significant transformations over billions of years. Understanding the complex interplay between the younger, more dynamic stars in the spiral arms and the older, more stable stars in the bulge is key to unraveling the evolutionary history of this galaxy. The interaction between the different components of NGC 6744 is not just limited to stellar formation. The galaxy's interstellar medium, ISM, made up of gas and dust, plays a crucial role in its ongoing evolution. The ISM in NGC 6744 is abundant, particularly in the spiral arms, where the pressure and density of the gas are high. As we observe these areas, we witness the birth of new stars, and the ISM itself provides the raw material from which these stars are made. However, the gas is not just an inert substance. It is actively influenced by the radiation and winds from newly formed stars, which push and heat the surrounding material. These processes, known as feedback mechanisms, help regulate the rate of star formation and contribute to the overall dynamics of the galaxy. In addition to stellar feedback, NGC 6744 is also home to an active stellar population, with a large number of young, hot stars scattered throughout its spiral arms. These stars are key to understanding the life cycle of galaxies, as their formation and eventual death influence the ISM and the overall evolution of the galaxy. Supernovae, the explosive deaths of massive stars, are common in galaxies like NGC 6744, and they have profound effects on the surrounding interstellar medium. The shock waves generated by supernovae can trigger further star formation, compressing nearby gas clouds and causing them to collapse into new stars. In this way, the life and death of stars within NGC 6744 play a crucial role in the continuous cycle of stellar birth and rebirth that defines the galaxy's dynamic evolution. Beyond the stars, NGC 6744's dark matter halo is another critical element in understanding its structure. Dark matter, the mysterious substance that does not emit or interact with electromagnetic radiation, makes up a significant portion of a galaxy's mass. Though it is invisible and detectable only through its gravitational effects, dark matter plays a crucial role in holding galaxies together. The distribution of dark matter within NGC 6744 is not uniform. Instead, it forms a vast, diffuse halo that extends far beyond the visible limits of the galaxy. This dark matter halo is responsible for the galaxy's overall gravitational potential and helps explain the observed rotation curve of the galaxy. By studying the way in which the stars in NGC 6744 move, astronomers can infer the presence and distribution of dark matter, further advancing our understanding of this elusive substance. NGC 6744 is also part of a larger group of galaxies, and as we examine the dynamics of galaxy groups, we gain valuable insights into the role of galactic interactions in shaping the evolution of individual galaxies. Galaxy groups are collections of galaxies that are gravitationally bound to one another, and they can range in size from just a few galaxies to hundreds, or even thousands. NGC 6744 is located near the outskirts of the Great Wall, one of the largest known structures in the universe, and its interaction with nearby galaxies may have played a significant role in its development. While NGC 6744 itself is not currently undergoing a major merger, its gravitational interactions with neighboring galaxies may have influenced its shape and star formation rate. As we continue to investigate NGC 6744, we also come across new methods for studying galaxies that will revolutionize our understanding of these cosmic giants. One of the most exciting developments in the study of galaxies is the advent of next-generation telescopes, such as the James Webb Space Telescope, JWST, and the Extremely Large Telescope, ELT. These powerful observatories will allow astronomers to observe galaxies like NGC 6744 in unprecedented detail, revealing new information about the galaxy's internal structure, star formation processes, and the role of dark matter. The JWST, with its advanced infrared capabilities, will be particularly valuable for studying the distant regions of NGC 6744 that are obscured by dust and visible light. In addition to new observational tools, advances in computational modeling are allowing scientists to simulate galaxy formation and evolution with greater accuracy. These models take into account the complex interactions between stars, gas, dust, and dark matter, and they allow researchers to test hypotheses about the forces that shape galaxies. By comparing the results of these simulations with real observations of galaxies like NGC 6744, astronomers can refine our understanding of the processes that govern galaxy formation and evolution. NGC 6744's study also contributes to one of the most fundamental questions in astrophysics: the origin and evolution of spiral galaxies. While much has been learned about the general processes that govern the formation of galaxies, there is still much to uncover about the specific mechanisms that give rise to spiral structures. The formation of spiral arms, the maintenance of a stable disk, and the role of central bulges in regulating galactic dynamics are all areas of active research. NGC 6744, with its well-defined spiral arms and central bulge, serves as an ideal laboratory for studying these processes in detail. Furthermore, NGC 6744's relationship with the cosmic web is crucial to understanding how galaxies evolve in response to their larger-scale environment. The cosmic web is a vast network of filaments made up of galaxies, dark matter, and gas, and it forms the largest known structure in the universe. NGC 6744's location near the edge of the Great Wall means that it is not only affected by the forces within its own group, but also by the larger-scale gravitational influences of this immense cosmic structure. As the study of the cosmic web advances, NGC 6744 will serve as an important case study for understanding how galaxies interact with their large-scale environment, and how these interactions influence their evolution. As our understanding of galaxies like NGC 6744 continues to grow, we are reminded of the vastness and complexity of the universe. Galaxies are not isolated objects, they are dynamic systems shaped by a multitude of forces. By studying NGC 6744, we not only learn about the galaxy itself but also gain valuable insights into the broader processes that govern the formation and evolution of galaxies across the universe. This knowledge helps to answer some of the most profound questions in science, and brings us closer to understanding the true nature of the cosmos. As we continue our exploration of NGC 6744, it becomes clear that studying this galaxy provides not just a glimpse into the complexity of the cosmos but also an understanding of the fundamental processes that govern the evolution of galaxies across the universe. There is still much to uncover, and as we look deeper into NGC 6744, we come face to face with its fascinating role in the cosmic narrative. The evolution of NGC 6744 offers valuable lessons about the formation of galaxies and their inner workings. Galaxies like NGC 6744, spiral in nature, are often thought to be among the most mature galaxies in the universe. They stand as an example of galaxies that have settled into a relatively stable state after undergoing significant transformations in their early years. When viewed against the broader backdrop of galactic evolution, this relatively stable phase is key in understanding how galaxies transition from chaotic, high-energy systems into the more orderly and structured forms we observe today. The journey of NGC 6744 mirrors the evolution of many other galaxies, though each galaxy's journey is influenced by its unique environmental conditions, interactions with nearby galaxies, and internal dynamics. To truly appreciate NGC 6744's significance, we must also consider how its various components interact with each other. The galaxy's disk, with its sweeping spiral arms, is home to an intricate system of gas clouds, young stars, and star-forming regions. The interstellar medium, ISEM, plays a key role in this dynamic, as it serves as the raw material from which new stars are born. The spiral arms of NGC 6744 are not static. Instead, they are constantly evolving. As gas clouds pass through the spiral arms, they are compressed by the gravitational forces at play, leading to the formation of new stars. These newly formed stars then emit intense radiation that heats the surrounding gas, further influencing the structure of the arms. Interestingly, the star formation rate in NGC 6744 is not uniform. In some areas, intense star-forming activity is occurring, while in others star formation is less pronounced. This patchiness in star formation is a characteristic feature of spiral galaxies and is often linked to the distribution of gas within the galaxy. In regions where the gas density is higher, star formation is more active, while in areas with less dense gas, the process slows down. This creates a dynamic, ever-changing environment within the galaxy, as regions of intense activity slowly give way to quieter regions, only to be replaced by new pockets of star formation. Understanding the rate and distribution of star formation in NGC 6744 is a critical part of piecing together the galaxy's evolutionary story. The role of dark matter is another fundamental aspect of NGC 6744's structure that warrants attention. Dark matter, an invisible substance that does not emit light, is believed to make up a significant portion of the mass of galaxies. Although dark matter cannot be seen directly, its presence is inferred through its gravitational effects on visible matter. In NGC 6744, the dark matter halo extends far beyond the galaxy's visible boundaries, and its gravity helps to hold the galaxy together. The mass of the dark matter halo is not uniformly distributed. Instead, it is more concentrated in the outer regions of the galaxy. This distribution of dark matter has a direct impact on the galaxy's rotation curve, a critical tool used by astronomers to study the mass and structure of galaxies. The rotation curve of NGC 6744, essentially the velocity at which stars and gas move around the center of the galaxy, shows a distinctive flat pattern. Unlike the rotation curves of smaller galaxies, where the velocity of stars decreases with distance from the galactic center, the stars in NGC 6744 continue to move at a relatively constant speed even at large distances from the center. This flat rotation curve is a strong indicator that dark matter is playing a significant role in the galaxy's dynamics, as the additional mass from dark matter is required to explain the high velocities of stars at the galaxy's outer reaches. The study of NGC 6744's dark matter halo also provides insight into the nature of dark matter itself. While dark matter remains one of the greatest mysteries in modern astrophysics, studying the distribution of dark matter in galaxies like NGC 6744 allows researchers to refine their theories about this enigmatic substance. Some theories suggest that dark matter is made up of particles that interact weakly with ordinary matter, while others propose that dark matter may consist of more exotic forms of matter, such as axions or WIMPs, weakly interacting massive particles. The data gathered from NGC 6744, alongside that from other galaxies, helps to shape our understanding of dark matter and its role in the evolution of galaxies. In addition to its internal structure and dynamics, NGC 6744's interactions with its larger cosmic environment are also key to understanding its evolution. The galaxy is part of a larger group of galaxies that are gravitationally bound to one another, and this group of galaxies is situated near the Great Wall, one of the most massive structures in the universe. The Great Wall is a vast network of galaxy clusters and superclusters that stretches across hundreds of millions of light-years. As part of this cosmic structure, NGC 6744 is not an isolated system but is instead influenced by the gravitational forces exerted by other galaxies and by the larger-scale distribution of matter in the universe. These gravitational interactions can have profound effects on galaxies, especially in terms of their shape and star formation activity. While NGC 6744 is not currently undergoing a major merger with another galaxy, it is still subject to the gravitational influences of neighboring galaxies. These interactions can lead to a variety of outcomes, ranging from the gradual accumulation of material from nearby galaxies to the triggering of star formation, or even the stripping of gas from the galaxy. As NGC 6744 continues to evolve, it is likely that its interactions with the larger cosmic web will continue to shape its future development. In the context of the cosmic web, NGC 6744 serves as an example of how galaxies are not isolated islands in space, but are instead part of a vast, interconnected structure. The cosmic web consists of long, thread-like structures that are made up of galaxies, dark matter, and gas. These threads of matter are arranged in a vast network, with galaxies and galaxy clusters located along the filaments. NGC 6744's position near the edge of the Great Wall places it within this larger network, where it is subject to the influences of its cosmic neighbors. Understanding the cosmic web is crucial for understanding the larger-scale structure of the universe and how galaxies evolve in response to the forces at play in this vast cosmic network. As we look toward the future of galactic research, new telescopes and advancements in computational techniques are opening up exciting possibilities for further studying NGC 6744 and other galaxies. The James Webb Space Telescope, JWST, which is set to launch in the near future, will allow scientists to study galaxies in unprecedented detail, providing new insights into their formation, evolution, and the role of dark matter. The JWST's advanced infrared capabilities will allow astronomers to observe the distant, hidden regions of galaxies like NGC 6744, including areas obscured by dust. This will provide a clearer picture of the processes that drive star formation, galaxy interactions, and the evolution of galaxies over cosmic time. Furthermore, new simulations and models of galaxy formation and evolution are allowing scientists to explore the conditions under which galaxies like NGC 6744 formed. These simulations take into account the complex interactions between stars, gas, dark matter, and other components of the galaxy, and they allow researchers to test different hypotheses about how galaxies evolve. By comparing the results of these simulations with real observations of galaxies, scientists can refine our understanding of the mechanisms that drive galactic evolution. NGC 6744 is not just a distant, isolated object in the universe. It is a window into the processes that have shaped the galaxies we see today. Its well-defined spiral structure, star-forming regions, dark matter halo, and interactions with its cosmic environment all offer valuable clues about how galaxies evolve. By studying NGC 6744, astronomers are able to unlock some of the most fundamental questions in astrophysics, such as how galaxies form, how they interact with each other, and how they evolve over billions of years. Ultimately, NGC 6744 serves as a reminder of the incredible complexity of the universe. The more we learn about galaxies like NGC 6744, the more we realize that the cosmos is a dynamic, interconnected system, shaped by a multitude of forces. As our understanding of NGC 6744 and other galaxies continues to grow, so too does our appreciation for the vastness and wonder of the universe itself. The beauty of NGC 6744 is not only in its structure but in the stories embedded in its spiral arms, its core, and its surrounding halo. When we look upon this galaxy, we're not simply observing a vast collection of stars. We're witnessing billions of years of cosmic history written in starlight. Each star within it holds secrets of nuclear fusion, gravitational struggle, and chemical evolution. To truly comprehend what NGC 6744 represents, we must dive even deeper, not just into its past, but into the fundamental physics and cosmic patterns that influence every component of its existence. Let's begin with the chemical composition of NGC 6744. Like other spiral galaxies, its stars and interstellar medium consist of varying amounts of hydrogen, helium, and heavier elements, often called metals in astronomical terminology. The distribution of these elements tells us much about the galaxy's past. In its central bulge, older stars dominate. These stars formed early in the galaxy's history, at a time when the interstellar medium had not yet been significantly enriched with heavier elements forged in stellar cores and supernovae. As we move outward from the core into the disk and spiral arms, we encounter increasingly younger stars, formed from more metal-rich clouds of gas, enriched by previous generations of stellar life cycles. This process, known as chemical evolution, is central to the study of galactic development. NGC 6744, with its orderly spiral structure and extensive star-forming regions, presents a nearly textbook example of chemical enrichment. Each supernova that erupts within it, each massive star that dies, contributes iron, oxygen, carbon, and other vital elements back into the interstellar medium. These elements eventually coalesce into new stars, planets, and possibly even life-supporting systems. If we could chemically map NGC 6744 in ultra-high resolution, we would see a gradient, a smooth transition from metal-poor stars near the core to more metal-rich populations in the outer disk. Interestingly, studying this metal distribution helps astronomers assess not only where stars are forming but also where star formation might have peaked in the past. In NGC 6744, the metal-rich spiral arms are likely the sites of ongoing star formation, with blue, hot stars lighting up the clouds around them. Meanwhile, the older, redder stars closer to the bulge tell the story of a more ancient time, when the galaxy was still taking shape. But stars alone do not tell the full tale. The galaxy's massive dust lanes, those dark, sinuous threads visible in deep optical images, play a crucial role in both blocking and catalyzing star formation. These lanes of interstellar dust are composed of tiny grains, often carbon or silicon-based, that absorb and scatter light, obscuring what lies behind them. They also cool gas clouds, allowing them to collapse more readily under gravity, triggering star birth. In NGC 6744, these lanes trace the spiral arms with exquisite precision, suggesting a self-regulating ecosystem in which dust, gas, and stars continually reshape one another. Now let's turn our attention to another important galactic feature, the galactic halo. This vast, spherical region surrounding NGC 6744 contains not only dark matter but also a sparse population of stars and globular clusters. These ancient clusters are among the oldest stellar systems in the universe, and they serve as a fossil record of the early epochs of galaxy formation. The globular clusters in NGC 6744 orbit far from the galactic plane and may have originated from dwarf galaxies that were consumed by NGC 6744 over the course of billions of years. These minor mergers, where smaller galaxies are gradually absorbed, are part of the ongoing process by which large galaxies grow in mass and complexity. The shape and distribution of the globular clusters in the halo can also reveal how chaotic or peaceful the galaxy's past has been. If many of the clusters exhibit highly elliptical orbits, or if their chemical compositions are significantly different from the stars in NGC 6744's disk, it may indicate a more tumultuous merger history. On the other hand, a uniform distribution of chemically similar clusters would point to a more stable evolutionary path. In either case, these clusters act like time capsules, preserving the history of NGC 6744's interactions with its surroundings. Another essential dynamic we must explore is the role of magnetic fields. Though invisible and difficult to measure, galactic magnetic fields influence the movement of charged particles, the formation of stars, and even the structure of spiral arms. In NGC 6744, as in other spiral galaxies, magnetic field lines are believed to run along the spiral arms, shaped by the rotation of the galaxy and the flow of ionized gas. These fields help guide the motion of cosmic rays and can impact the alignment and rotation of dust grains. While magnetic fields are often overlooked in popular discussions of astronomy, they are a key force operating on galactic scales. In terms of observation, NGC 6744 has been studied in multiple wavelengths, from visible light to radio waves, from infrared to X-rays. Each wavelength reveals different facets of the galaxy's structure and behavior. For example, infrared observations allow astronomers to peer through dust and see the older, cooler stars that lie behind it. Ultraviolet light highlights hot, young stars, making it an excellent tool for studying star-forming regions. X-ray observations can reveal the presence of black holes, neutron stars, and high-energy interactions such as supernova remnants. In NGC 6744, faint X-ray emissions may signal the presence of a central supermassive black hole, quietly influencing the behavior of the galaxy's core. Speaking of the core, we cannot ignore the potential activity hidden within NGC 6744's nucleus. While the galaxy does not currently show signs of being an active galactic nucleus, AGN, it may well house a dormant supermassive black hole, as is believed to be the case in the Milky Way. These massive objects, often millions or billions of times the mass of the Sun, reside at the center of most large galaxies. When material falls into them, it releases vast amounts of energy, sometimes outshining the entire galaxy. Even in its dormant state, the black hole in NGC 6744 may be quietly influencing stellar orbits and gas dynamics near the core. Understanding the central black hole's mass, spin, and feeding behavior can offer critical insights into the life cycle of the galaxy. Is the black hole growing? Is it influencing star formation through its gravitational pull or the release of energetic particles? Is it surrounded by an accretion disk or torus of material that could eventually reignite its activity? These questions drive a major portion of extragalactic astrophysics, and NGC 6744 is a key candidate for study due to its similarity to the Milky Way. Zooming out, we must also consider NGC 6744 in the context of cosmic time. This galaxy, while vibrant and active today, is not immune to the long-term fate that awaits most galaxies. Over billions of years, its star formation will slow as the supply of gas is depleted. Its spiral arms may fade, and the galaxy may evolve into a more featureless lenticular or elliptical form. It may continue to cannibalize smaller galaxies, grow its central black hole, and expand its halo. Eventually, its stars will age and die, and the galaxy will fade into the background of an increasingly dark and empty universe. And yet, while NGC 6744's ultimate fate may be one of quiet decline, its present moment is full of dynamic activity and wonder. It is a living laboratory for astrophysics, a twin of our own Milky Way that lets us test theories, examine processes, and gaze into our own galactic mirror. Through continued observation and modeling, scientists will deepen our understanding of this magnificent structure, drawing ever closer to the answers to some of the universe's most profound questions. As we push the boundaries of technology and knowledge, future missions and observatories will no doubt reveal even more about galaxies like NGC 6744. Whether it's through gravitational wave detection, neutrino astronomy, or next-generation telescopes that can map the entire sky in exquisite detail, the next era of galactic exploration promises to be even more thrilling than the last. In the grand narrative of cosmic evolution, NGC 6744 stands as a stunning and indispensable chapter, a chapter not only in the history of galaxies but in the pursuit of understanding where we come from and where we might be going. To truly appreciate this galaxy, we must continue our journey beyond its physical components and into the dynamic processes that govern its shape, motion, and long-term evolution. Let us now delve into the dynamic architecture of NGC 6744, a structure that has been molded by billions of years of gravitational ballet. The galaxy's well-defined spiral arms are not static features. They are the result of density waves moving through the disk. These waves act like cosmic traffic jams, compressing gas clouds as they move, which in turn triggers the birth of new stars. It's in these high-density zones that we see the brilliant clusters of young, blue stars lighting up the spiral arms like celestial lanterns. But how do these density waves form? One popular explanation is the Linsu density wave theory, which proposes that the arms are not fixed arrangements of stars and gas but rather patterns that move more slowly than the material within the galaxy. As stars and gas orbit the center of the galaxy, they periodically bunch up along these waves, much like cars piling up on a highway during rush hour. This elegant theory helps explain the persistence of spiral structures over vast timescales. In NGC 6744, The clarity of these arms makes it a near-perfect candidate to study the accuracy of this theory in real cosmic conditions. Further adding to the complexity of NGC 6744's structure is the phenomenon of galactic bars. Although this galaxy is classified primarily as a barred spiral, its central bar is subtle, much less prominent than in galaxies like NGC 1300 or our own Milky Way. Bars are elongated structures of stars that extend from the central bulge and help funnel gas inward toward the galactic center. This inward flow can fuel both star formation and the growth of central black holes. Even a faint bar, like the one in NGC 6744, can exert significant gravitational influence, reshaping the inner dynamics of the disk and driving activity in the core. Another fascinating aspect of NGC 6744 is its rotation curve, a graph that shows how the velocity of stars and gas changes as a function of distance from the galaxy's center. In a Newtonian universe governed solely by visible matter, we would expect objects farther from the center to move more slowly, much like planets in our solar system. However, observations consistently show that stars in the outer regions of spiral galaxies, including NGC 6744, orbit at speeds that remain constant, or even increase. This discrepancy is one of the key pieces of evidence for the existence of dark matter, an invisible substance that exerts gravitational influence, but emits no light. The rotation curve of NGC 6744, like those of other spirals, suggests that a significant portion of its mass is not in stars, gas, or dust, but in a vast halo of dark matter. This dark halo extends well beyond the visible limits of the galaxy, and is critical for maintaining its structure and dynamics. Without the additional gravitational pull provided by dark matter, the galaxy's stars would not orbit as they do. They would simply drift away into space. Studying the rotation curve of NGC 6744 helps refine models of dark matter distribution and provides critical input into simulations of cosmic structure formation. On the subject of simulations, it's important to note that galaxies like NGC 6744 are often used as analogs in cosmological models. These simulations, such as the Illustris or Eagle projects, attempt to recreate the universe's evolution from the Big Bang to the present day using billions of particles and complex physics. By comparing the properties of simulated galaxies to those observed in NGC 6744, scientists can test the accuracy of their models and fine-tune the variables that govern everything from star formation rates to merger histories. NGC 6744's role as a Milky Way twin makes it especially valuable in this regard. Since we are embedded within the Milky Way and cannot view it from the outside, NGC 6744 provides a rare opportunity to see what a similar galaxy looks like in its entirety. It gives us an external perspective on spiral structure, halo dynamics, and satellite interactions, features we can only infer from within our own galactic boundaries. This makes every new observation of NGC 6744 not just a glimpse into its own character, but a mirror held up to our cosmic home. Speaking of satellite interactions, let's explore the smaller companion galaxy, NGC 6744a. This irregular satellite is believed to be gravitationally bound to NGC 6744 and may be undergoing a slow tidal disruption. As it orbits its massive host, gravitational forces stretch and distort its shape, stripping away stars and gas that may eventually be assimilated into NGC 6744's halo. This process, known as tidal stripping, is a common mechanism through which large galaxies grow over time. It also provides a natural laboratory for studying the behavior of stars and gas in low-gravity environments. The interaction between NGC 6744 and NGC 6744a also raises questions about the past. Did the larger galaxy absorb other satellites in the distant past? Are there tidal streams, long ribbons of stars left behind by disrupted galaxies, circling its halo? If so, detailed imaging in the infrared or ultraviolet could reveal these faint structures, helping astronomers reconstruct the galaxy's accretion history. Each of these encounters leaves a mark, not just in the form of extra stars, but in the angular momentum, chemical composition, and shape of the galaxy. One might wonder whether NGC 6744 has any potential for habitable planets. Though we currently lack the resolution to observe individual planets in that galaxy, we can make educated guesses. Based on its mass, metallicity, and star formation rate, it's plausible that NGC 6744 hosts billions of Earth-like planets. Statistically, many of these may reside in habitable zones, regions around their stars where temperatures allow for liquid water. If life developed in NGC 6744 as it did on Earth, there could be countless worlds teeming with biology, from microbial life to intelligent civilizations. That thought alone gives NGC 6744 an almost mythic quality. It transforms from a distant smudge of light into a sprawling stage where life might be playing out in ways both familiar and alien. Could civilizations in NGC 6744 have built radio telescopes? Could they be sending signals, hoping to be heard across the void? These are tantalizing questions that push the limits of both science and imagination. They compel us to keep searching, to keep looking up, and to keep asking what role humanity plays in this incomprehensibly vast cosmos. Moreover, the philosophical implications of galaxies like NGC 6744 cannot be overstated. Each spiral arm, each glowing nebula, each silent black hole forces us to confront the scale of the universe and our place within it. NGC 6744 is not just a distant object of study, it is a symbol of what we do not yet understand, of the mysteries that continue to call to us from across the abyss of space. With every new piece of data, each photon that travels millions of years to reach our detectors, we uncover another layer of complexity. We see that the universe is not static, but alive with motion, growth, decay, and rebirth. NGC 6744 reminds us that galaxies are not islands, but ecosystems, interconnected, evolving, and deeply rich in phenomena that challenge and inspire. And yet, for all that we know, so much remains hidden. What processes drive the exact shape of spiral arms over billions of years? How do magnetic fields evolve with time? What is the true distribution of dark matter in its halo? Are there rogue stars wandering between galaxies that were once part of NGC 6744? What unknown particles or forces shape the behavior of galaxies on the grandest scales? As we continue to build better instruments and launch more ambitious missions, whether space telescopes like JWST or future observatories like LUVOIR and the 30-meter telescope, we inch closer to answers. With every passing decade, NGC 6744 reveals a bit more of itself. But even as it does, it keeps the biggest questions just out of reach, reminding us that the universe is as much a mystery as it is a revelation. We must carry forward the sense of awe, curiosity, and reverence that such a galaxy deserves. It is a masterpiece of nature, a swirling city of stars where the laws of physics and the poetry of existence blend into something truly sublime. The richness of NGC 6744 does not simply lie in its observable features, but in the invisible tapestry of forces that have shaped it over time. From the earliest stirrings of gas collapsing into stars to the gravitational influence of dark matter halos, every aspect of this grand spiral galaxy is bound to a set of interwoven narratives, each one deeper, more profound, and more intricate than the last. Now, let us continue our journey by zooming in further, not just on the stars and the spiral arms, but on the interplay of stellar populations, the life cycles of stars, and the symphony of radiation they emit across the electromagnetic spectrum. In NGC 6744, just as in the Milky Way, stellar populations fall into distinct generations, broadly categorized as Population 1 and Population 2 stars. Population 1 stars are metal-rich, younger, and generally found in the galactic disk, especially within the spiral arms. These stars form from interstellar gas that has been enriched by previous generations of supernovae, meaning they contain heavier elements like carbon, nitrogen, oxygen, and even iron. It is within this population that we find stars capable of forming planetary systems like our own, an environment where complex chemistry and, potentially, life can thrive. Meanwhile, Population 2 stars are much older and metal-poor, relics from the early universe. They are often found in the central bulge and halo of the galaxy. These stars tell us about the galaxy's formative years, preserving the chemical fingerprint of a time when the cosmos was still young, and only hydrogen and helium were abundant. In NGC 6744, astronomers have used spectral analysis to identify both these populations, allowing them to map not just where stars are, but when they were born and from what material. To probe even deeper, scientists examine globular clusters, dense, spherical groups of ancient stars that orbit the galaxy's center. These clusters are considered some of the oldest structures in any galaxy, and in NGC 6744, a number of such clusters have been identified. Each globular cluster can contain hundreds of thousands of stars, packed so tightly that their mutual gravity forms a cohesive structure. The ages, compositions, and orbits of these clusters serve as time capsules, unlocking information about the early assembly of NGC 6744's halo and bulge. Now let us turn to another crucial component of galactic anatomy, the interstellar medium, ISM. This is the vast expanse of gas and dust that fills the space between stars. It's not empty, nor is it uniform. It is turbulent, dynamic, and essential for the birth and death of stars. In NGC 6744, the ISM exists in multiple phases, from cold molecular clouds to hot ionized plasma. Each phase interacts with the others through feedback processes, stellar winds, supernova explosions, and radiation pressure. Molecular clouds, composed mostly of hydrogen molecules H2, are the cool, dense nurseries where stars are born. These clouds can collapse under their own gravity, fragmenting into dense cores that eventually ignite nuclear fusion. In NGC 6744, these clouds are especially prominent in the spiral arms, which act as compression waves, triggering star formation on massive scales. Observations using radio and submillimeter telescopes, such as ALMA, can trace these clouds by detecting emissions from molecules like carbon monoxide (CO), which acts as a proxy for hydrogen. Once stars form, they exert powerful feedback on the ISM. Massive stars produce intense ultraviolet radiation that ionizes surrounding hydrogen, creating glowing regions known as H2 regions. These are visible in the optical range and appear as bright pinkish patches in color-enhanced images of NGC 6744. The radiation and stellar winds from these young stars carve out cavities in the gas, sometimes compressing nearby regions and triggering further star formation in a chain reaction. But star formation is not the only contributor to the ISM's evolution. Supernovae, cataclysmic explosions of dying stars, play a monumental role. When massive stars exhaust their nuclear fuel, they collapse under gravity and rebound in an explosion that ejects heavy elements into the surrounding space. These explosions inject energy, heat, and enriched material into the ISM, stirring it up and changing its composition. In NGC 6744, supernova remnants can be identified through X-ray emissions and shockwave structures that extend for dozens of light years. In parallel, the dust component of the ISM plays a crucial role in both blocking and reprocessing light. Dust grains, composed of silicates, carbon compounds, and ices, absorb ultraviolet and visible light from stars and re-emit it in the infrared. Infrared observations of NGC 6744 reveal a network of dust lanes interwoven through the spiral arms, tracing regions of intense star formation and cooling gas. These dust lanes often appear dark in optical images, silhouetting the stars behind them. Now we must consider the high-energy aspect of NGC 6744, specifically, the X-ray and gamma-ray emissions that hint at some of the most extreme environments in the galaxy. These emissions can come from a variety of sources, accreting black holes, neutron stars, massive binaries, and even diffuse hot gas. While NGC 6744 lacks an active galactic nucleus, meaning its central black hole is currently quiescent, it may have once been active in the past. Evidence of faint X-ray sources near the core suggests ongoing, albeit minimal, accretion activity. Farther out, high-energy emissions also signal the presence of X-ray binaries, systems in which a compact object like a black hole or neutron star siphons matter from a companion star. As the material spirals inward, it heats up and emits X-rays. These systems are relatively rare but incredibly luminous, and their presence in NGC 6744 helps chart the population of evolved stellar remnants scattered throughout the disk. The magnetic fields of NGC 6744 form another invisible but essential component. Though difficult to detect directly, these fields influence the motion of charged particles and help shape the structure of the ISM. They play a role in star formation, cosmic ray propagation, and even the alignment of dust grains, which can polarize starlight. Observations using radiopolarimetry reveal that NGC 6744, like many spiral galaxies, has a coherent large-scale magnetic field that follows the spiral arms, an elegant and mysterious feature that ties together stellar and interstellar phenomena. Meanwhile, cosmic rays, high-energy particles that travel near the speed of light, zip through the galaxy, influenced by both magnetic fields and supernova activity. These particles originate from powerful sources like supernova remnants and possibly from the galaxy's core. Though invisible, cosmic rays contribute to the heating of the ISM and can even affect the chemistry of interstellar clouds, altering the conditions for star and planet formation. And what about the chemical evolution of NGC 6744? Every star that forms and dies contributes to the enrichment of the galaxy's gas. Over billions of years, this ongoing recycling leads to a steady increase in metallicity, the abundance of elements heavier than hydrogen and helium. By analyzing the spectral lines of stars and gas, astronomers can determine the metallicity gradient of the galaxy. Typically, metallicity is highest in the core and decreases toward the outskirts, reflecting the longer star formation history in the central regions. This gradient not only tells us about the galaxy's history but also its future. Regions with high metallicity are more likely to form rocky planets, as the building blocks for such worlds require metals like silicon, iron, and magnesium. Thus, the chemical landscape of NGC 6744 is not just a record of its past, but a predictor of what kinds of planetary systems it might host. Taken together, the stellar populations, ISM, high-energy phenomena, magnetic fields, and chemical gradients form a portrait of NGC 6744 as a living, breathing entity. It is a galaxy in motion, not just through space, but through time, evolving with every star that ignites, every cloud that collapses, every atom that is forged and scattered. But still, we have only scratched the surface. To truly comprehend the grandeur of NGC 6744, we must expand our vision beyond static images and momentary snapshots. Galaxies are dynamic, unfolding over epochs that stretch from the birth of the universe to the far-flung future. NGC 6744, like all spiral galaxies, is caught in this unending dance of matter and motion, structure and entropy. As we continue to unravel its story, we turn our attention to the subtle processes that dictate galactic evolution, secular changes, radial migration, and gravitational interactions both internal and external. Secular evolution refers to slow, gradual changes in the structure of a galaxy driven by internal mechanisms rather than cataclysmic events like mergers. In NGC 6744, these processes have likely shaped its spiral arms, central bulge, and bar, if a bar exists at all. While observational data remain somewhat inconclusive about the presence of a central bar, spiral density wave theory suggests that the elegant, sweeping arms of NGC 6744 owe their shape to gravitational instabilities propagating through the disk. These arms are not rigid structures, nor do they rotate like the hands of a clock. Instead, they represent regions of enhanced density, like traffic jams in the flow of stars and gas. As material orbits the galactic center, it slows down in these denser regions, giving rise to compression, shock waves, and ultimately, new stars. The spiral arms act as both catalysts and signposts of galactic renewal. In the midst of these structural transformations, individual stars and stellar systems are not confined to their birthplaces. Over time, stars can migrate radially, moving closer to or farther from the galactic center. This radial migration occurs through complex interactions with spiral arms, resonances, and even molecular clouds. A star born in the inner disk of NGC 6744 might find itself drifting outward over billions of years, carrying its chemical signature and kinetic energy with it. This redistribution of stars blurs the once clear metallicity gradient and adds richness to the galaxy's population structure. Moreover, the gravitational influence of satellite galaxies and nearby systems cannot be ignored. Though NGC 6744 is relatively isolated, it does have at least one known satellite galaxy, NGC 6744A, which may have interacted with its host in the past. These interactions, even when mild, can stir up the disk, trigger bursts of star formation, and induce the formation of tidal streams, faint trails of stars pulled from one galaxy by another. Observing these features in NGC 6744 helps piece together its interaction history, much like the streams of stars observed around the Milky Way have revealed its own cannibalistic tendencies. The possible existence of such tidal streams around NGC 6744 invites further inquiry. Deep field imaging with high sensitivity and resolution may yet uncover these ephemeral traces. If discovered, these streams could contain clues about past mergers, revealing both the mass and composition of the galaxies NGC 6744 has absorbed or disrupted. Each tidal stream would be a chapter in its cosmic autobiography, chronicling ancient collisions and gravitational conquests. On a larger scale, NGC 6744's position within the cosmic web must also be considered. Though it is not a member of the local group, it resides in the direction of the Pavo constellation and is part of a loose aggregation of galaxies. These group environments are crucial to understanding how galaxies evolve, as they determine the likelihood of close encounters, gas accretion from the intergalactic medium, and the rate at which galaxies consume or expel material. Indeed, gas accretion is an often underappreciated factor in a galaxy's growth. For star formation to continue over billions of years, galaxies must replenish their supply of cold gas. In NGC 6744, there is evidence of extended HI, neutral hydrogen, gas enveloping the disk, suggesting ongoing accretion from its surroundings. This process could be smooth, with intergalactic gas slowly spiraling inward, or it could involve clumps and filaments falling onto the disk. Either way, this inflow feeds the cycle of star birth and sustains the galaxy's luminous activity. Conversely, galaxies can also lose gas through outflows driven by supernova winds, radiation pressure, and even the motion of the galaxy through the intergalactic medium. These outflows can quench star formation by removing the raw materials needed to build new stars. In the case of NGC 6744, the balance between inflow and outflow determines its long-term star-forming potential. If gas loss outpaces replenishment, the galaxy will eventually enter a quiescent phase, dimming over eons as its remaining stars age and die. To assess this delicate balance, astronomers employ a technique known as the star formation rate, SFR, which measures how many solar masses of stars are created per year. In NGC 6744, this rate is estimated to be slightly higher than in the Milky Way, owing to its somewhat greater mass and size. By examining emissions in ultraviolet and infrared wavelengths, proxies for young, massive stars and dust heating, respectively, scientists can infer the current SFR and compare it to historical averages preserved in the distribution and color of stars. This temporal dimension adds yet another layer to the galaxy's profile. Like tree rings in a cross-section of wood, the ages of stars encode information about past conditions. By measuring the spectra of different stellar populations, researchers can reconstruct the galaxy's star formation history, identifying epochs of rapid growth, relative quiet, and resurgence. These fluctuations may be tied to internal processes like bar instabilities or external triggers like mergers and flybys. Another vital metric in understanding NGC 6744 is its stellar mass. By modeling the luminosity and accounting for mass-to-light ratios across different bands, astronomers estimate that NGC 6744 contains tens of billions of solar masses and stars alone. This makes it one of the most massive galaxies in its region of the sky, another similarity it shares with our Milky Way. When dark matter is factored in, the total mass balloons to hundreds of billions of solar masses, most of which is invisible and detectable only through gravitational effects. Dark matter itself is a critical player in the structure and stability of NGC 6744. Though we cannot see it, we know it is there by studying the galaxy's rotation curve. If the visible matter were all there was, the stars on the outskirts of the galaxy would orbit much more slowly than they actually do. Instead, observations show that rotation speeds remain high even far from the core, implying the presence of an unseen halo of mass enveloping the galaxy. This dark matter halo acts like scaffolding, binding the galaxy together and shaping its interactions with the universe. And yet, dark matter is only part of the mystery. There is also the tantalizing question of dark energy, an even more enigmatic force believed to drive the accelerated expansion of the universe. While NGC 6744 itself is not expanding, the space between it and other galaxies is stretching at an ever-increasing rate. This cosmic expansion will eventually isolate galaxies like NGC 6744 in vast, dark voids, as their neighbors recede beyond the observable horizon. In this distant future, galaxies will become cosmic islands, self-contained, drifting in an ocean of nothingness. But until that time comes, NGC 6744 remains part of a rich and dynamic cosmos. It is a crucible of formation and decay, of order and chaos. It contains the seeds of future stars, the ruins of past explosions, and the potential for entire civilizations within its exoplanets, if they exist. It is an archive, a laboratory, and a beacon of light, straddling the line between known and unknown. To understand NGC 6744 is to understand more than a galaxy. It is to grasp the vast interplay of matter, energy, time, and chance that gives rise to the structures we see. It is to witness the evolution of the universe written in starlight and shadow. And it is a reminder that every galaxy, no matter how distant or faint, is a world unto itself, deserving of study, reverence, and awe. NGC 6744, in all its splendor, offers a cosmic narrative that intertwines the lives of stars, clouds of gas and dust, gravitational forces, and invisible components like dark matter. But beyond its grand structural features and galactic interactions lies a rich subtext told through its individual stellar populations. Every star in NGC 6744, from its youngest hot blue giants to its ancient, fading red dwarfs, contributes a verse to the poetic saga of this galaxy. The diversity and distribution of these stars help astronomers decode the galaxy's past, its formation epochs, and even the nature of the primordial matter that gave it birth. Stellar populations are broadly classified into three groups: population 1, 2, and 3 stars. While population 3 stars remain theoretical, believed to be the universe's first stars, composed almost entirely of hydrogen and helium, population 1 and 2 stars are observable in galaxies like NGC 6744. The younger, metal-rich population 1 stars are typically found in the spiral arms where star formation is active. Their short lifespans, often just a few million years, mean they don't wander far from their birthplace before ending their lives as supernovae or compact remnants. These young stars emit strong ultraviolet radiation, which ionizes the surrounding gas and creates glowing regions known as H2 regions. Observations of NGC 6744 show several such bright, pinkish zones, marking stellar nurseries where gravity has overcome pressure to condense interstellar gas into new suns. These regions serve as hotbeds for studying star formation in action. The mass, composition, and arrangement of stars within these nebulae reveal not only how stars form but also how they influence the surrounding environment through stellar winds, radiation, and eventual supernova explosions. Population 2 stars, in contrast, are older and metal-poor, indicating they formed earlier in the galaxy's history when fewer heavy elements were available. These stars are generally found in the galactic bulge and halo, particularly within globular clusters, dense, spherical collections of tens of thousands to millions of stars bound by gravity. NGC 6744, like the Milky Way, hosts a population of such clusters. The age and metallicity of globular clusters offer a fossil record of the early conditions in the galaxy, giving us clues about how it assembled over time. One of the more subtle yet significant components of a galaxy's ecosystem is its interstellar medium, ISEM, the gas and dust that fills the space between stars. In NGC 6744, the ISM plays a vital role in recycling material from dead stars into new generations of stars. This medium is composed of several phases: cold molecular clouds where stars are born, warm atomic gas, hot ionized gas, and dust grains that absorb and scatter starlight. Dust, though only a small fraction of the ISM by mass, has a disproportionate effect on observations. It dims and reddens the light from stars, making them appear fainter and cooler than they actually are. Astronomers studying NGC 6744 use multiple wavelengths to peer through the dust and construct a more complete picture of the galaxy. In the radio spectrum, neutral hydrogen emissions map the large-scale distribution of gas. In the infrared, dust reprocessed starlight reveals hidden star-forming regions. In X-rays, astronomers can detect high-energy phenomena like supernova remnants, accreting black holes, and hot gas bubbles created by intense stellar winds. This multi-wavelength approach is essential, as no single band can capture the galaxy's full complexity. Black holes also play a pivotal role in galactic ecosystems, and while NGC 6744 is too distant for us to directly observe individual stellar mass black holes, we can infer their presence. These objects are born from the core collapse of massive stars and may lurk unseen throughout the spiral arms. More intriguing is the possibility that NGC 6744 harbors a supermassive black hole, SMBH, at its center, much like the Milky Way's Sagittarius A star. Although it's challenging to detect such a black hole in NGC 6744 without high-resolution spectroscopy, the presence of a central bulge and the similarities to our own galaxy strongly suggest one exists. SMBHs influence their host galaxies in profound ways. When actively feeding, they generate energetic outflows and jets that can regulate star formation by heating or expelling gas, a process known as active galactic nucleus (AGN) feedback. While NGC 6744 does not currently display strong AGN activity, its central region may have cycled through active phases in the past, especially during interactions or mergers that funneled gas toward the nucleus. Such mergers are not rare in the life of a galaxy. Over cosmic time, large galaxies grow by cannibalizing smaller ones, a process vividly observed in other nearby systems like the Andromeda Galaxy. In NGC 6744's case, signs of past mergers may exist in its extended stellar halo, faint tidal features, or in the disturbed motion of stars in the outer disk. Future surveys with sensitive telescopes could uncover these subtle relics of ancient collisions, helping to reconstruct the galaxy's assembly history. One of the most fascinating frontiers in galactic astronomy is the search for exoplanets and potential habitability. While direct detection of exoplanets in NGC 6744 is currently beyond our technological reach due to its distance, we can speculate based on stellar demographics. The presence of numerous sun-like stars, combined with a steady star formation rate and relatively calm environment, makes it plausible that planetary systems exist throughout NGC 6744. The question of life, therefore, extends far beyond the confines of our Milky Way. Even though we may never explore these alien worlds firsthand, their potential existence reminds us of the universality of physics and chemistry. The same processes that formed Earth and the solar system could very well be at work in distant spiral arms of NGC 6744. Water, carbon-based molecules, and energy from stars are not unique to us. They are the products of widespread cosmic conditions. In the far future, the fate of NGC 6744 will be determined by cosmic time scales that dwarf human comprehension. Stars will continue to form, burn, and die. Planetary systems will evolve or perish. Slowly, the supply of cold gas will dwindle, and the galaxy will enter a phase of decline, its brilliant spiral arms fading into a dim, red haze. This red and dead state, seen in elliptical galaxies today, marks the endpoint of galactic life cycles. Eventually, all stars will fade, and only remnants, white dwarfs, neutron stars, and black holes, will remain. Over trillions of years, even these will decay or be ejected, leaving behind a dark, empty shell. NGC 6744, like all galaxies, is not eternal. It is a transient pattern in the fabric of the cosmos, a beautiful structure carved from chaos, destined to dissolve back into it. But before that distant twilight, NGC 6744 will continue to shine. It will light the way for astronomers seeking to understand the universe's grand design. It will inspire questions about our place in the cosmos, the origins of life, and the nature of existence itself. And it will remain, as it always has been, a reminder of the astonishing complexity and beauty that emerges from the simple laws of physics. To contemplate NGC 6744 is to gaze not just across space, but across time. It is to see the universe not as a static canvas, but as a living, breathing entity, evolving, creating, and eventually fading. In every glowing star, in every swirling nebula, in every silent void, there is a story. And NGC 6744 is one of the most eloquent storytellers in the night sky. As we continue to peel back the layers of NGC 6744, we encounter the deeper, more subtle components of this galaxy's structure. While the dominant features, its grand spiral arms, its bright central nucleus, and its massive star-forming regions, captivate our imaginations, it's the smaller, seemingly insignificant elements that often hold the keys to understanding the true nature of a galaxy. These elements, when observed in detail, reveal the history, the dynamics, and the very essence of what NGC 6744 is and how it fits into the broader cosmic landscape. One of the most compelling aspects of any galaxy, including NGC 6744, is the distribution of its stellar populations. While we often think of galaxies in terms of their grand spiral structure or their centralized bulges, the way that stars are distributed within a galaxy tells a far more intricate story about its evolution. The stellar populations of NGC 6744 are a reflection of the galaxy's formation history, providing astronomers with clues about the processes that led to its current state. The younger stars, located primarily in the spiral arms, are the product of the most recent star formation events in the galaxy. These stars are typically formed in dense molecular clouds, where gravity causes gas and dust to collapse, igniting nuclear fusion and creating newborn stars. NGC 6744, with its well-defined spiral arms and active star formation regions, is a perfect example of a spiral galaxy undergoing an ongoing process of stellar birth. This star-forming activity is primarily concentrated in the outer arms of the galaxy, which are rich in gas and dust, materials that are essential for the formation of new stars. These regions are characterized by the presence of large, young, and massive stars that burn through their fuel quickly, often ending their lives in dramatic supernova explosions that enrich the surrounding space with heavier elements. In contrast, the older stars, found in the galactic bulge and halo, tell the story of the early history of NGC 6744. These stars are thought to have formed long before the more recent starbursts in the arms. The bulge itself, a dense and luminous concentration of stars in the center of the galaxy, is home to some of the oldest stars in NGC 6744. These stars are often cooler and dimmer than their younger counterparts, but they are crucial for understanding the galaxy's early evolution. Many of the stars in the bulge are red giants, remnants of an earlier time when the galaxy was still assembling its mass and structure. The galaxy's halo, a diffuse region that extends beyond the visible disk, is another key area of interest. Here, astronomers observe populations of stars that are even older and less chemically enriched than those in the bulge. These stars are thought to have formed during the galaxy's initial phases of growth, before the spiral arms had fully developed. The presence of these ancient stars in the halo provides strong evidence for the idea that NGC 6744, like most galaxies, has gone through a complex process of accretion, where it has gradually built up its mass over time through the merger and accretion of smaller galaxies. In addition to its stellar populations, NGC 6744 also harbors a rich diversity of other celestial objects, such as star clusters, nebulae, and supernova remnants. Star clusters, both open and globular, are among the most fascinating components of any galaxy. In NGC 6744, the presence of numerous star clusters adds another layer of complexity to the galaxy's structure. Open clusters, which are relatively young and contain only a few hundred stars, are typically found in the spiral arms, where new stars are still forming. Globular clusters, on the other hand, are much older and more tightly bound, containing thousands to millions of stars. These clusters are often found in the galactic halo, where they have likely been in existence since the early stages of the galaxy's formation. Nebulae, the colorful clouds of gas and dust that glow in the presence of young, hot stars, are another striking feature of NGC 6744. These nebulae are the sites of active star formation, where the raw materials for new stars are gathered and compressed by gravity. Some of the most famous nebulae in other galaxies, such as the Orion Nebula and the Milky Way, are similar to those found in NGC 6744. These regions are rich in hydrogen, the most abundant element in the universe, and are often observed in the infrared and radio wavelengths to study the dense, cold gas that is invisible in visible light. These nebulae provide a glimpse into the process of stellar birth, revealing how stars like our Sun might have been born billions of years ago. Supernova remnants, the remains of massive stars that have exploded in catastrophic supernova events, are also an important component of NGC 6744. These remnants are often seen as expanding shells of gas and dust, the product of a star's final, explosive death throes. In these remnants, astronomers can observe the intense shockwaves and the dispersal of heavy elements like iron and carbon, which are synthesized in the cores of massive stars before they explode. These elements are then scattered into the interstellar medium, where they will be incorporated into new generations of stars, planets, and possibly even life itself. The dynamic interactions between stars, gas, and dust in NGC 6744 are further complicated by the galaxy's gravitational forces. As a spiral galaxy, NGC 6744 experiences constant gravitational interactions between its stars, gas, and dark matter. These interactions cause stars and gas to move in complex orbits around the galaxy's center, which in turn drives the formation of the galaxy's spiral structure. The presence of dark matter, an invisible form of matter that does not emit light but exerts a gravitational pull, plays a crucial role in these interactions. Dark matter is thought to make up the majority of the mass in NGC 6744, and its gravitational influence helps to stabilize the galaxy and keep its spiral arms intact. Over time, the gravitational interactions between the stars and gas in NGC 6744 will continue to shape the galaxy's structure. While the spiral arms remain a defining feature of the galaxy, their appearance is not fixed. As stars move through the arms, they cause the gas to compress, triggering further star formation and reinforcing the spiral pattern. This process is known as spiral density wave theory, and it helps to explain why galaxies like NGC 6744 maintain their spiral structure over long periods of time. In addition to these internal interactions, NGC 6744 is not isolated in the cosmos. Like most galaxies, it is part of a larger cosmic network, interacting with nearby galaxies through gravity. These interactions can lead to tidal forces that distort the galaxy's shape, triggering bursts of star formation, or even causing the galaxy to merge with others. While NGC 6744 is not currently in the midst of a merger, it is possible that it has experienced such interactions in the past, and its spiral structure may have been influenced by these past encounters. Over the course of millions and billions of years, NGC 6744 will continue to evolve. As stars continue to form and die, and as gas and dust continue to cycle through the galaxy, NGC 6744 will undergo a gradual transformation. The galaxy will eventually exhaust its supply of star-forming gas, and the spiral arms will fade, leaving behind an elliptical galaxy. This transformation is a common fate for many spiral galaxies, as they gradually run out of the raw materials needed to sustain star formation. Ultimately, the future of NGC 6744 will be shaped by the larger-scale forces of the universe. While the galaxy is currently a vibrant, star-forming spiral, its fate is tied to the ongoing evolution of the universe itself. As the universe continues to expand and galaxies move further apart, the interactions between galaxies will become less frequent. However, the interactions that have already taken place will have left their mark on NGC 6744, shaping its structure and its stellar populations for billions of years to come. NGC 6744 is a dynamic, evolving galaxy that offers a fascinating window into the processes that govern the formation and evolution of galaxies in the universe. From its active spiral arms and star-forming regions to its ancient stellar populations and the remnants of past supernovae, NGC 6744 tells a story of cosmic transformation. As we continue to study this galaxy, we learn not only about its own history but also about the broader processes that shape galaxies across the universe. And as we gaze into its depths, we are reminded of the beauty and complexity of the cosmos, where each galaxy, no matter how far away, holds a unique story waiting to be discovered. The story of NGC 6744 does not merely end with its stars, gas, and dust. It expands into the realm of galactic environments, cosmic time, and intergalactic influence. Though often viewed through the lens of a single galaxy, the reality is that NGC 6744 exists as part of a larger tapestry of celestial structures, all woven together by the invisible threads of gravity, dark matter, and cosmic history. To fully understand the significance of NGC 6744, we must place it within this broader cosmic web and examine how it interacts with, reflects, and contributes to the evolving structure of the universe. At the scale of the universe, galaxies are not isolated islands. Instead, they are components of galaxy groups, clusters, and superclusters. These structures are defined by the gravitational attraction of dark matter halos that pull galaxies into vast, interconnected systems. NGC 6744 belongs to a small group of galaxies, sometimes referred to as the NGC 6744 group. This group includes a few smaller galaxies, such as the irregular galaxy NGC 6744A, which orbits nearby and may have even interacted with NGC 6744 in the past. These smaller companions provide important context for the history of NGC 6744, especially in terms of gravitational influence and potential mergers. Interactions between galaxies are not just random occurrences. They are critical events that can alter the entire structure and evolution of a galaxy. When a large galaxy like NGC 6744 passes near or collides with another galaxy, the gravitational forces involved can twist, stretch, and distort both participants. These tidal forces can induce new waves of star formation as gas clouds are compressed, or they can strip gas from a galaxy, quenching star formation entirely. If NGC 6744 has undergone any such interactions in its past, remnants of those events may be visible in its extended halo, tidal streams, or warped outer arms. Some astronomers suspect that its outermost spiral arms may already be subtly distorted, possibly the result of a long-past gravitational encounter. Studying these tidal features is crucial because they are time capsules, preserving the evidence of events that occurred hundreds of millions or even billions of years ago. In the low surface brightness outskirts of NGC 6744, astronomers can search for stellar streams, trails of stars pulled from dwarf galaxies or satellite systems that once orbited the galaxy. These streams are exceedingly faint but incredibly important, as they trace the hierarchical growth of galaxies. NGC 6744, like our Milky Way, likely grew through the accumulation of smaller galaxies, many of which were shredded and absorbed over time. But even beyond tidal interactions, the chemical composition of NGC 6744 tells another rich tale. Astronomers analyzed the spectra of stars and nebulae in the galaxy to determine the abundances of various elements, such as hydrogen, helium, oxygen, and iron. These elements are the byproducts of nuclear fusion within stars and the explosive release of material during supernova events. By measuring the relative abundances of these elements in different parts of the galaxy, scientists can reconstruct the history of star formation and chemical enrichment. For instance, the central bulge of NGC 6744 is expected to be chemically richer than the outer spiral arms, since it has experienced more generations of star formation and supernovae. This metallicity gradient, from the inner regions of the galaxy to the outer arms, mirrors what we observe in many spiral galaxies, including the Milky Way. It also supports the idea of inside-out galaxy formation, where the central parts of the galaxy form stars earlier and more rapidly, while the outer regions grow more slowly over time. This gradual outward growth is supported by the discovery of young, metal-poor stars in the farthest reaches of NGC 6744's disk, indicating ongoing star formation in previously quiet areas of the galaxy. The ongoing star formation activity in NGC 6744 is powered not only by its internal gas supply but also by gas accretion from the intergalactic medium. Galaxies are not closed systems. They can absorb diffuse hydrogen from the space around them. This inflowing gas can sustain star formation for billions of years, provided that it is not blocked or heated by external factors. In the case of NGC 6744, its isolated position in the local group gives it access to relatively unimpeded reservoirs of cosmic gas, helping to fuel the bright star-forming regions observed in its spiral arms. Moreover, NGC 6744 likely hosts a supermassive black hole at its center. This assumption stems from our understanding that virtually all large galaxies, especially spirals with significant bulges, possess black holes with masses ranging from millions to billions of times the mass of the Sun. While NGC 6744's central black hole has not been definitively measured, indirect evidence, such as the velocity of stars near the galactic center and the dynamics of surrounding gas, suggests that such a black hole exists. Though currently quiet, these central black holes can become active during periods of intense accretion, emitting powerful jets and radiation that can impact the surrounding interstellar medium. The energy emitted by an active galactic nucleus, AGN, can either trigger or suppress star formation. In some cases, the AGN drives outflows of hot gas that compress the surrounding material, leading to new star formation. In other cases, it heats or expels the gas, preventing stars from forming. For NGC 6744, its apparent inactivity today does not preclude a more violent past. During its history, it may have experienced episodes of intense AGN activity, particularly during or after galactic mergers, which are known to drive large amounts of gas into the center of galaxies. Moving beyond NGC 6744 itself, the galaxy's light provides insights into its motion and orientation in space. Spectroscopic observations allow astronomers to determine the galaxy's redshift, how much its light has been stretched due to the expansion of the universe. For NGC 6744, its redshift corresponds to a distance of about 30 million light-years, placing it comfortably within the local universe. The rotational velocity of the galaxy can also be measured through the Doppler shift of hydrogen gas. This information is used to construct rotation curves, which in turn reveal the presence of dark matter. NGC 6744's rotation curve, like those of many other spiral galaxies, remains flat at large distances from the center, meaning that stars in the outer arms orbit just as fast as those closer in. This observation contradicts what we would expect based on visible matter alone, and strongly suggests the presence of an unseen mass component, dark matter. This mysterious form of matter does not emit, absorb, or reflect light, but its gravitational influence is undeniable. In fact, the majority of NGC 6744's mass is thought to be dark matter, enveloping the galaxy in a massive, roughly spherical halo that extends far beyond the visible disk. This dark matter halo is essential for understanding the galaxy's stability and long-term evolution. Without it, the outer stars and gas clouds would not be gravitationally bound and would simply drift away into intergalactic space. The halo not only anchors the galaxy's structure but also plays a role in how it interacts with other galaxies. If and when NGC 6744 merges with another galaxy, the dark matter halos of both galaxies will collide and merge first, setting the stage for the visible components to come together. But the journey of NGC 6744 is far from over. Like all galaxies, it exists within the framework of cosmic time, subject to the eventual fate of the universe itself. Over the next few billion years, NGC 6744 will continue to age, gradually transforming as its gas is consumed, its stars age and die, and its structure slowly changes. Eventually, as its spiral arms fade and star formation ceases, NGC 6744 may resemble a lenticular or elliptical galaxy, an ancient, red-hued remnant of its former self. Yet even then, the story continues. The stars that once lit up the galaxy will remain, orbiting silently in the dark, perhaps accompanied by white dwarfs, neutron stars, and black holes. The light from these ancient stars will continue to travel across the cosmos, bearing witness to the beauty and complexity of a galaxy that, for a brief moment in cosmic time, was vibrant with creation, structure, and movement. And from Earth, as long as we look up with the right tools and the curiosity to understand, we will see that soft, spiral smear of light in the constellation Pavo and know that it is more than just a distant galaxy. It is a living archive of cosmic history. A galactic fingerprint of time, motion, and mystery, silently spiraling through the universe. As we continue our exploration of NGC 6744, it becomes clear that this galaxy is not only a stellar object of immense beauty and interest, but a powerful reminder of the interconnectedness of all things in the cosmos. Every galaxy, including NGC 6744, exists within a vast and ever-expanding universe, bound together by the fundamental forces of nature, yet also shaped by unique processes that reflect the complexity and mystery of the cosmos. Looking more closely at the environment surrounding NGC 6744, we see that its position in the universe is far from an isolated one. Despite being located about 30 million light-years away, it is part of the local supercluster, a vast collection of galaxies, clusters, and dark matter that includes our own Milky Way. NGC 6744 is situated within the Pavo group, a smaller galaxy group that also includes a number of nearby companions. In this sense, NGC 6744 is just one of countless galaxies in a constantly evolving, interactive web of cosmic structures. The presence of companion galaxies in the Pavo group is of particular interest. Interactions between galaxies in close proximity are often responsible for the creation of certain unique features within galaxies, such as tidal tails, bridges of stars, and unusual star formation patterns. As NGC 6744 and its companions orbit one another in this group, gravitational forces between them can produce subtle changes in their shapes and trajectories. While NGC 6744 itself appears relatively calm and symmetric, its neighbors may provide clues to the more dynamic processes that have occurred in the past. As we delve deeper into the cosmic history of NGC 6744, it's important to consider the role of gas and dust in shaping the galaxy's evolution. The vast clouds of interstellar gas and dust that fill the space between stars are far more than just passive components. They are the raw material for new stars. The presence of these clouds, especially in the spiral arms of NGC 6744, is a clear sign that star formation is actively occurring in the galaxy. The dense molecular clouds in the arms of NGC 6744 are the sites where new stars are born, and these regions are often associated with bright nebulae, such as H2 regions, where young, hot stars ionize the surrounding gas. These regions of intense star formation also give us clues about the physical conditions within NGC 6744. The hot, young stars that form in these nebulae are short-lived and burn through their fuel quickly, leaving behind remnants like white dwarfs, neutron stars, and black holes. As these stars age and die, they release energy into the surrounding gas, enriching it with heavier elements such as carbon, oxygen, and iron. This process of stellar nucleosynthesis, along with the subsequent dispersal of these elements into the interstellar medium, leads to the chemical evolution of galaxies over time. The star formation in NGC 6744's spiral arms is an ongoing process. However, star formation is not evenly distributed across the galaxy. In some regions, such as the outer arms, star formation is less intense, while the inner regions, particularly the central bulge, show signs of being older and more chemically evolved. This difference in star formation rates and chemical composition suggests that NGC 6744 has evolved over a long period of time, with the central region having formed stars earlier in its history and the outer arms continuing to experience bursts of star formation. The central bulge of NGC 6744, which is densely populated with older stars, provides us with further insight into the galaxy's history. Bulges are thought to form early in a galaxy's life, as stars cluster together in the central regions, possibly through the process of violent mergers and accretion events. The stars in the bulge of NGC 6744 are often older and have a higher metal content than those in the disk, which further supports the idea that the galaxy's central region formed first. These older stars, often red giants or asymptotic giant branch stars, provide a stark contrast to the younger, hotter stars found in the outer spiral arms. The presence of a central black hole is another key feature of NGC 6744, though it remains relatively quiet at present. Supermassive black holes, such as the one believed to reside in NGC 6744, are found in the centers of most large galaxies. These black holes are not only central to the dynamics of their host galaxies, but also play a significant role in regulating the growth of the galaxy itself. In periods of intense activity, when large amounts of gas are funneled toward the black hole, it can become an active galactic nucleus, AGN, emitting massive amounts of energy and influencing the surrounding gas and stars. This energy can either trigger or inhibit star formation, depending on the conditions. However, despite its immense mass, the black hole in NGC 6744 appears to be in a relatively dormant phase, with little evidence of the powerful outflows and radiation typical of an active galactic nucleus. The study of NGC 6744 provides a unique window into the complex processes that govern the life cycles of galaxies. From the dynamics of its spiral arms to the quiet activity of its central black hole, NGC 6744 is a microcosm of the larger processes that drive the evolution of galaxies throughout the universe. Its relatively calm state, with active star formation in the arms and an older, more stable central region, serves as a reminder that galaxies, like all living things, have a finite lifetime and will eventually undergo significant changes as they evolve. Looking to the future, NGC 6744's fate is inextricably linked to the ongoing dynamics of the galaxy group to which it belongs. Galaxies in close proximity to one another, especially those in a group like the Pavo group, are subject to gravitational interactions that can lead to mergers, accretion, and other dramatic events. Over the course of billions of years, NGC 6744 may merge with one or more of its companions, reshaping its structure and potentially leading to the formation of a larger elliptical galaxy. Alternatively, NGC 6744 could continue to exist as a relatively isolated spiral galaxy, continuing to form stars in its arms while slowly aging over time. One of the most intriguing possibilities is that NGC 6744 may eventually interact with the Milky Way itself. While this may seem like a distant prospect, the motion of galaxies within the local group suggests that such interactions are inevitable. Over the next few billion years, NGC 6744 and the Milky Way may begin to move toward one another, potentially leading to a merger. If this happens, the two galaxies could collide, sending shockwaves through the interstellar medium and triggering bursts of star formation. The central black holes of both galaxies would eventually merge, creating a supermassive black hole that could be the centerpiece of the new, larger galaxy. This cosmic collision could lead to the transformation of both galaxies into a single, elliptical galaxy, though not without first undergoing a period of intense, chaotic interactions. As we look back on NGC 6744 and its place in the universe, we are reminded of the immense scale and complexity of the cosmos. From its spiral arms filled with young stars to its quiet central bulge, from its dark matter halo to its potential future interactions with other galaxies, NGC 6744 is a living example of the dynamic processes that govern the universe. It is a story written in the stars, a narrative that spans billions of years and will continue for billions more. In the grand scheme of things, NGC 6744 is but a small piece of the vast cosmic puzzle, yet it is a piece that holds immense significance. It is a galaxy that, like all others, has a story to tell, one of star formation, gravitational interactions, and cosmic evolution. And as we peer deeper into its heart, using the tools of modern astronomy, we uncover more about not only NGC 6744 itself but the larger forces at play in the universe, forces that shape the destiny of galaxies, stars, and even entire cosmic structures. The future of NGC 6744 remains unknown, but for now, it continues to shine brightly in the sky, a testament to the beauty, complexity, and mystery of the universe. As we continue our deep dive into the captivating world of NGC 6744, it's essential to step back and reflect on the larger implications of what we've discovered so far. Every galaxy, including NGC 6744, serves as a reminder that the universe is vast, dynamic, and constantly evolving. This particular galaxy, though far away, holds clues to the processes that shape not only its own destiny but also the fate of other galaxies, including our very own Milky Way. The Milky Way and NGC 6744 share more than just the same broad spiral galaxy classification. They share fundamental properties and structures that echo across billions of light-years of space. As we look at the shape of NGC 6744, its spiral arms, dense stellar populations, and intricate web of interstellar gas, it's easy to see how similar it is to our own galaxy. This reflection between galaxies allows astronomers to draw comparisons, helping us better understand our own position in the cosmos. What sets NGC 6744 apart from other spiral galaxies is its remarkable size and its high degree of symmetry. While some spiral galaxies appear somewhat irregular due to collisions or gravitational influences, NGC 6744 is visually striking for its near-perfect proportions. Its spiral arms extend outward in smooth arcs, and the galactic core is neatly centered. But even with such symmetry, the galaxy's true nature is hidden beneath the surface, in the myriad of physical and chemical processes that occur in its heart and beyond. The star-forming regions of NGC 6744, in particular, are a testament to the ongoing life cycle of stars. The interaction between the galaxy's gas clouds and young stars forms the building blocks for the next generation of celestial bodies. This continuous formation is not without consequence. It drives the expansion of the galaxy, modifies its shape, and influences the chemical composition of the interstellar medium. The gas that is present in the spiral arms, much of it in molecular clouds, is being converted into new stars at a steady rate. These stars, like the ones found in the Orion Nebula in our own galaxy, are the engines that power the galaxy's bright blue spiral arms, fueling an ongoing cycle of stellar birth and death. It's worth noting that while star formation dominates the outer regions of NGC 6744, the inner regions of the galaxy are home to a different kind of energy. The central bulge, as we mentioned before, houses older, redder stars that have already gone through their own cycle of formation and have settled into a more stable phase. These stars are often less massive and cooler than their younger counterparts, making the center of NGC 6744 appear distinctly yellowish compared to the more luminous blue of the arms. These stars are remnants of a past era, a reflection of the galaxy's formative years. Their presence highlights an interesting phenomenon in galaxy formation. The core of a spiral galaxy like NGC 6744 can be thought of as a relic of the past, a preserved piece of the galaxy's history. Another important element that warrants further investigation is the dark matter halo that surrounds NGC 6744. Like most large galaxies, NGC 6744 is enveloped by a vast halo of dark matter, a mysterious substance that cannot be observed directly but whose presence is inferred through its gravitational effects. This dark matter halo plays a crucial role in the galaxy's structure and dynamics. It influences the rotation curve of the galaxy, meaning that the stars and gas in the outer reaches of NGC 6744 are moving faster than would be expected based on the visible matter alone. Without the additional mass provided by the dark matter halo, NGC 6744's spiral arms would not be able to maintain their shape and structure over time. The study of dark matter, especially in galaxies like NGC 6744, is one of the most important ongoing quests in astrophysics, as it may hold the key to understanding the nature of the universe itself. The presence of a supermassive black hole at the center of NGC 6744 is another intriguing feature that deserves attention. Supermassive black holes are found at the cores of most galaxies, and they serve as the gravitational focal point for the galaxy's matter. In the case of NGC 6744, however, the black hole is not currently an active one. It seems to be relatively quiet compared to other galaxies with active galactic nuclei, AGN. This calmness might suggest that the black hole is in a dormant phase, having already consumed much of the surrounding gas and stellar material. However, as we've seen in other galaxies, such dormant black holes are known to flare to life in bursts, sometimes reaching an active state again. The future of NGC 6744's central black hole is uncertain, but its potential to become an AGN in the future remains a fascinating possibility. Furthermore, the gas clouds that surround NGC 6744 are not only a raw material for future stars, but also a key component in the galaxy's overall dynamics. These clouds are not static. They are constantly in motion, responding to the forces acting upon them, including the gravitational pull from NGC 6744's stellar population and dark matter halo. As gas clouds move and interact with one another, they undergo processes that can lead to the formation of new stars, but they can also be disrupted and torn apart. The constant cycling of gas in and out of the galaxy helps to maintain the balance of star formation, preventing the galaxy from running out of the raw materials it needs to sustain its stellar population. In addition to the gas and star formation, we must also consider the broader cosmic context in which NGC 6744 exists. It is part of a galaxy group, and its gravitational interactions with neighboring galaxies have a profound impact on its shape and evolution. Even in the quiet phase that NGC 6744 is experiencing right now, gravitational interactions with its neighbors can still exert subtle influences. These interactions might not be immediately visible in the form of dramatic collisions or mergers, but over long periods of time, they could lead to shifts in the galaxy's star formation rates, changes in the orbits of stars, and even subtle alterations in its spiral structure. One of the most intriguing aspects of NGC 6744's evolution is how it fits into the broader picture of galactic evolution. Galaxies like NGC 6744, with their large spiral arms, are believed to be relatively mature. However, this maturity doesn't mean that NGC 6744 is simply a static, unchanging system. Galaxies like this one are constantly evolving, driven by a complex interplay of factors such as gas inflows, star formation, supernovae explosions, black hole activity, and tidal interactions with other galaxies. As such, NGC 6744 is still undergoing a process of cosmic maturation, one that will continue for billions of years. The future of NGC 6744, shaped by the ongoing dynamics of the universe, is as uncertain as it is fascinating. Looking toward the future, there are two possible paths that could shape NGC 6744's destiny. First, the galaxy may continue to evolve relatively peacefully, with gradual changes in its star formation rates and structural characteristics. This is the more likely scenario, given the current lack of any major disturbances or imminent interactions with nearby galaxies. However, over the course of billions of years, even the most stable galaxies will eventually undergo dramatic changes. NGC 6744 may eventually experience an interaction with another nearby galaxy, or perhaps a collision with another galaxy in the Pavo group. Such events would lead to significant structural changes, possibly triggering bursts of star formation or the merging of supermassive black holes. The collision between galaxies, though catastrophic in the short term, often results in the formation of a new, larger galaxy, sometimes an elliptical galaxy with a completely different appearance. Alternatively, NGC 6744 could eventually interact with the Milky Way itself, which is slowly moving toward the Andromeda galaxy. In the distant future, such interactions could send ripples across the entire region, altering the shape and structure of many galaxies in the local group. The final fate of NGC 6744 could involve merging with the Milky Way or Andromeda, or it could remain on its own trajectory, evolving as an isolated island of stars in a vast, ever-expanding universe. As we continue to explore the mysteries of galaxies like NGC 6744, it becomes increasingly apparent that the cosmos is a place of constant change. Galaxies, like the stars they contain, live and die, grow and shrink, collide and merge. NGC 6744 is but one example of this magnificent and chaotic process, and as we learn more about it, we uncover more about the grand, cosmic story that unfolds across billions of years. As we continue this exploration of NGC 6744, let us shift focus to the technological advancements that have allowed us to understand this galaxy in such detail. The study of distant galaxies like NGC 6744 is possible due to a combination of cutting-edge telescopes, sophisticated imaging techniques, and advancements in computational models. These tools allow astronomers to observe galaxies billions of light-years away, piecing together intricate details of their structure, star formation, and even their interaction with the surrounding environment. Telescopes such as the Hubble Space Telescope have been pivotal in studying galaxies like NGC 6744. With its advanced optics and ability to capture images in various wavelengths of light, from visible to ultraviolet and infrared, the Hubble Space Telescope has provided us with some of the most stunning images of distant galaxies. NGC 6744 has been one of the galaxy's many subjects, revealing intricate details of its spiral arms and dense central bulge. The clarity and sharpness of Hubble's images have enabled astronomers to study the distribution of stars, the movement of gas clouds, and even the effects of dark matter in unprecedented detail. These images have not only expanded our knowledge of NGC 6744 but have also provided insight into how galaxies form, evolve, and interact with one another. However, Hubble is not the only telescope that has contributed to our understanding of NGC 6744. The Very Large Telescope, VLT, located in Chile, has also played an important role in observing this galaxy. The VLT, part of the European Southern Observatory, ESO, uses a suite of instruments to capture high-resolution images and spectra, allowing astronomers to study the galaxy's stellar populations, gas clouds, and even its supermassive black hole. With its array of powerful instruments, including the FLAMES spectrograph and the MUSE integral field unit, the VLT has provided detailed observations of NGC 6744's internal dynamics. These tools enable scientists to measure the velocity of stars and gas within the galaxy, map the distribution of various elements, and even detect the influence of dark matter. Additionally, radio telescopes like the Atacama Large Millimeter/Submillimeter Array, ALMA, have opened new avenues for observing galaxies such as NGC 6744. ALMA allows astronomers to study the cooler regions of galaxies, including the dense molecular clouds that are the birthplaces of new stars. By observing NGC 6744 in the radio spectrum, scientists can trace the gas that fuels the galaxy's ongoing star formation. This provides a complementary view to the optical and infrared observations, giving us a fuller understanding of the galaxy's evolution and the physical processes at work within it. The study of NGC 6744 has also benefited from advancements in computational modeling. Modern simulations of galaxy formation and evolution allow astronomers to test different scenarios for how galaxies like NGC 6744 form, grow, and interact with their environments. These models use vast amounts of data collected from observations to simulate the behavior of gas, stars, and dark matter over billions of years. By running these simulations, astronomers can predict the future of NGC 6744 and test hypotheses about its past, helping to refine our understanding of galactic evolution. One of the key insights from these simulations is the recognition that galaxies like NGC 6744 are not isolated objects. They are part of a larger cosmic web, interacting with neighboring galaxies and gas clouds, and evolving as part of an interconnected system. Another important aspect of the study of NGC 6744 is the ongoing investigation into the role of galaxy clusters and the gravitational interactions that occur within them. NGC 6744 is part of a small group of galaxies, the Pavo group, and its interactions with other members of this group are of particular interest to astronomers. The gravitational pull between these galaxies can influence their shapes, star formation rates, and even the distribution of dark matter. Studying these interactions provides valuable insight into how galaxies evolve as part of larger structures in the universe. It also sheds light on the processes that lead to galaxy mergers, which are thought to be a key driver of galactic evolution. The future of NGC 6744, as with all galaxies, is intertwined with the larger cosmic evolution of the universe. The universe is constantly expanding, and over the course of billions of years, galaxies will continue to change, collide, and merge. NGC 6744's fate may be shaped by interactions with other galaxies in the Pavo group, or it may eventually merge with the Milky Way or Andromeda, forming a new, larger galaxy in the process. Such mergers are not unusual in the cosmic timeline and are believed to have played a significant role in the formation of many of the galaxies we see today. As astronomers look deeper into the distant future of galaxies like NGC 6744, they are also investigating the ultimate fate of the universe itself. Current theories suggest that galaxies will continue to evolve as the universe expands. Over time, galaxies will drift farther apart, and the number of observable galaxies in the sky will decrease as they recede beyond the cosmic horizon. In the farthest reaches of the universe, galaxies like NGC 6744 may eventually fade from view, their light stretched out beyond the reach of our instruments. However, this distant future is still billions of years away, and for now, galaxies like NGC 6744 continue to shine brightly in the vastness of space. In many ways, the study of NGC 6744 and other distant galaxies is a search for understanding not only of these faraway systems, but of our own place in the cosmos. By studying the evolution of galaxies like NGC 6744, we gain insight into the processes that shaped our own Milky Way galaxy. We begin to understand the forces that drive star formation, the role of dark matter, and the way galaxies interact and evolve over time. NGC 6744 serves as a cosmic laboratory, a place where scientists can study the fundamental processes that govern the universe. The lessons learned from NGC 6744 extend far beyond the boundaries of this galaxy alone. As we look at NGC 6744 and other similar galaxies, we gain clues to the larger cosmic story, one that spans billions of years and encompasses the birth, life, and eventual death of stars, galaxies, and even the universe itself. Each discovery, each new piece of information, brings us closer to answering the fundamental questions that have fascinated humanity for millennia. How did the universe begin? How will it end? And what is our place in the vast, ever-expanding cosmos? NGC 6744, like all galaxies, is a story in progress, a living, breathing entity that continues to evolve, shaped by the forces of gravity, gas, and light. Its beauty lies not only in its structure but in the incredible complexity of the processes that shape its future. As our tools and knowledge continue to advance, we are sure to learn even more about this fascinating galaxy, uncovering the mysteries of the universe one discovery at a time. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.